Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are now in the session of room 3. Yes, there are several speakers. Firstly, I would like to invite Professor Ahmad Fitriadli from Department of Maritime Technology, Faculty of Ocean Engineering, Technology and Informatics, University Malaysia, Terengganu. Are you available, Professor Ahmad Fitriadli? Okay, Professor Ahmad Fitriadli, if you already you can share your presentation. You have 15 minutes for presentation and 5 minutes for discussion. So I think you have time until 10:17. Okay, Professor Ahmad Fitriadi, are you ready? Professor Ahmad still not ready yet, I think. Anyone from the organizer can contact him. Okay, Professor Ahmad. Please respond to our room. Professor Ahmad, are you hear me? Are you hearing me? Okay, because I think Prof. Ahmad not ready yet, so I will invite to the first presentation for the parallel section. Maybe Prof. Ahmad can join later. Mm, there are nine presentation for this session of parallel session. First, I invite Mr. Nabil Amirul Haq or Ms. Komsin or Mr. Danar for the presentation of the paper titled The Design of an Arduino-based low-cost ultrasonic tight gauge with Internet of Things system. Are you ready for the presentation? For the parallel session, we have 10 minutes for presentation and 2 minutes for discussion. Mr. Nabil, already joined this room? Do you ready? Nabil.
I'm ready.
Okay. You can begin your presentation, sharing your screen, and you have 10 minutes for presentation.
Uh, I I have sent my pre-recorded video to
Okay,
the
no problem.
screen
Okay.
because my internet connection is very bad now.
Okay, you can share your video.
Please wait.
Entitled The Designs of an Arduino-based low-cost ultrasonic light gauge with the Internet of Things or IoT system. First, I will explain to you about the resource background. Why I choose these topics is because of these three problems. The first problem is the importance of types data, which has various functions such as to determine the chart datum or vertical reference, to correct arithmetic data, and many more. To get precise state data, we can use two methods, such as manual test observation and using test gauge instrument. But test gauge instrument on Indonesian market is still quite expensive. It costs at 30 million until 95 million rupiah. And the other problem is not all coastal area in Indonesia have test station. There are only 138 test stations in Indonesia. Why I choose Arduino? Because it is cheap and the software is open source, compatible with various modules and sensor. The connection between sensor to Arduino is very easy. Just plug and play using cable connector. The research location is located at two different places and time. The first research is to test the ultrasonic dead gauge instrument. It is located at PT Pelindo Marine Service Jetty on 14 until 16 February 2020. The testing of this instrument lasted for 48.5 hours. And the second is to test the GPS module, because on April, I decided to add GPS module to get sensor coordinate or instrument coordinate. The test is located at Gripik Village Soccer Field, Kudus Regency, Central Java, Indonesia. This is the tools and material that I use for this research. The material is the component that needed to build the ultrasonic dead gauge. There are 10 main components such as Arduino Mega, ultrasonic sensor, temperature sensor, Wi-Fi modules, SD card modules, real-time clock or RTC modules, GPS module, LCD, AC to DC adapter, and then microcontroller with has module Wi-Fi on it. And the tools is MATLAB for data processing and Arduino IDE for instrument programming. There are 4 stages on this research. The first stage is instrument design and build, and the second stage is instrument testing. On the instrument testing stage, I test the instrument with also doing manual test observation using test stack. This is the instrument configuration on the testing side. The third stage is data processing. I use MATLAB for data filtering using moving average and moving median methods. The fourth stage is instrument accuracy test by comparing instrument data with manual observation data using root mean square error and relative error calculation. This is the result of electrical circuit design. The number 1 is ultrasonic sensor, number 2 is temperature sensor, number 3 is Wi-Fi module, number 4 is SD card module, number 5 is real-time clock modules, number 6 is LCD, number 7 is power supply, number 8 is not MCU microcontroller, number 9 is GPS module, number 10 is Arduino. The function of this component is shown on this. The first is ultrasonic sensor, main sensor. The temperature sensor is for speed of sound in the air correction. Wi-Fi module to catch Wi-Fi signal and send data to ThinkSpeak server. SD card module for data pickup if the internet connection is very weak. Real-time clock module is to give time information in the tides data. LCD is to display the current times and tides elevation on the LCD. The power supply is for energizing the instrument. Microcontroller plus Wi-Fi, not MCU, to run GPS module and send GPS data to ThinkSpeak server because the Arduino pin is already full. And the number 9 is GPS module to get coordinate data. And number 10 is the main microcontroller of this instrument, Arduino Mega. The function is to get run our connected modules and sensor. This is the instrument body design. There are 2 components on this instrument. The first is electrical component box. This box is water resistant. The function is to protect electrical component in the box. And the second component is sensor arm. It has ultrasonic sensor transducer and temperature sensor. And the sensor arm is can be assembled with the TED stack. This is the instrument body new design. I use new box to protect the electrical component, and there are several ports to connect with the computer for programming. This is the ThinkSpeak IoT server. I choose this server because ThinkSpeak is open source. This is the instrument manufacturing cost. The total cost to make this instrument is 2 million rupiah. This is TIDES data at ThinkSpeak server. There are two problems on this data. The first is noise, and the second is delay. This is the SD card data. There are 412 more data on this SD card because the delay on the ThinkSpeak server. This is the data from GPS module. I extract the latitude and longitude from the GPS. This is the manual observation of TIDES data. The interval of the observation is 30 minutes. This is the result of filtering method. I use moving average and moving median methods. This is the overlay of manual observation TIDES data with the filtered data. This is the instrument accuracy test result. Conclusion. First, in this research, low-cost ultrasonic dead gauge instrument was created which has 2 million rupiah or only 7.5% of the lowest dead gauge price on the Indonesian market. The second, the instrument accuracy test result shows the relative error and root mean square error values for raw data is 0.226% and 9.926 millimeter, 29 millimeter. For moving average is 0.936% and 18.542 millimeter. For the moving median data is 0.437% and 13.242 millimeter. With the best filtering method is moving median. However, this low-cost ultrasonic dead gauge instrument still has two problems, such as noise and delay. Thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you to Mr. Nabil for the interesting presentation. I invite the audience, if you have any question, you can ask to Mr. Nabil directly or by chat room. You can also type down your question. We have still 2 minutes for discussion. If any of you have any question. Okay, maybe I want to ask you a little bit question about your observation. I noticed noise, yes, noise of
sir.
your result. What is the cause of the noise? It is from the device or from the wave? You know, in your ocean or in a coastal, there is a wave that is periodically, it is probably at around 10 seconds or 11 seconds or 12 or around that periods, or it is from the device. of the noise. You have any idea about that? You know what I mean? You measure tide, right? Pasang surut. Tapi tadi ada noise ya. Noise itu mungkin disebabkan oleh gelombang ya. Kalau pasang surut kan periodenya panjang tuh. Bisa 12 jam ya kan. Kalau gelombang kan cepat nih datangnya ya. Tiap 12 detik gitu, 12 detik, 10 detik, atau 15 detik. Nah, itu noise itu apakah karena gelombang atau karena memang alatnya sendiri, electricity-nya gitu maksud saya.
Ya, yang pertama kemungkinan pertama itu karena sensornya. Nah, soalnya sensor yang saya gunakan itu relatif murah lah. Kalau dikatakan cuma Rp150.000 harganya. Yang pertama sensornya kalau menurut saya. Terus yang kedua, pada saat pengujian itu terjadi saat musim penghujan, sehingga misalnya bacaan sensor suhu yang ada di instrumen saya itu sering mengalami fluktuasi karena hujan terus. Jadi koreksi kecepatan suara yang dihasilkan berubah-ubah dan menyebabkan jarak yang berubah-ubah juga. Yang kemudian kondisi di lapangan sih. Yang pertama karena banyak sampah di permukaan lautnya. Terus ada juga pas kesalahan teknis, yaitu kabel konektornya itu terputus karena terkena panas di landangan besi, sehingga harus disambung dan menghasilkan noise yang nilainya 0.
Okay,
So
thank you very much for your. Okay, no problem. From who?
Yeah, from Fitriadi, University Malaysia Terengganu. Sorry, just now actually I should be here
no
for
problem.
the invited speaker, isn't it?
Okay, yeah, go ahead.
Yeah, so just now I have a technical problem. Just want to ask you regarding to your presentation. So I'm not fully attending your presentation, but regarding to the title for the tide gauge. So do you measure the wave height? I mean the amplitude of the wave height?
I measure the surface elevation.
Yeah, surface elevation. So normally the sensor is recording the acceleration, isn't it? And then how to convert from the acceleration to be displacement?
I use the formulation of distance because this instrument is so. I measure the distance because this instrument is measure the traveled wave of speed of sound like that, and then I use the formulation of distance is velocity times with period or per 2 like that. Repeated play 2.
So I mean, mostly we just do the integration, isn't it? To get the velocity. After that, we get displacement. So I think just asking you, do you use the MATLAB software, or maybe using the National Instrument software to integrate the value from the acceleration to be the displacement? So this is just my question.
Oh, I don't do that.
Did you do like that?
No, I only just measure the distance between sensor transducer to the water surface.
Okay, thank you.
Okay.
Okay, thank you, Dr. Subekti.
Okay. Thank you, Prof. Ahmad, for your question. So I think it's now your turn to presentation, and you already past the time.
Yeah.
Okay, you have 15 minutes to presentation, and after that we have 5 minutes to discussion.
Okay.
Time is yours.
Okay. So, Assalamualaikum warahmatullahi wabarakatuh and very good morning. So,
Waalaikumsalam.
firstly, I do apologize for the delay. Yeah, some technical problem happened to me here. Not further ado, I would like to start my presentation here regarding to the challenge and alternative solution development of optimized twin ponton floating breakwater. So let me introduce myself here. My name Ahmad Fitriadi. I'm from the Department of Maritime Technology, University Malaysia Terengganu. So before that, I would like to attract your attention regarding to this topic. I would like to show you the little animation regarding to the, fixed breakwater. So we can see from this video, this, one of the solution how to prevent the coastal area from the erosion. So the existing design mostly using the fixed breakwater. So from the animation, we can see that the wave energy transmission is sufficiently reduced by this by this fixed breakwater. However, some limitation also occurs from the fixed breakwater, especially for the economical perspective of view. Regarding to the cost, the fixed breakwater is much higher compared to the floating breakwater. So what I would like to present here regarding to the floating breakwater. So some benefit obtained from the floating breakwaters is also promising as compared to the fixed breakwater. So this, the simulation that we have conducted in our laboratory. And finally, I would like to inform here that we try to analyze this floating breakwater using the 2D analysis involving the potential theory. And after that, we try to enhance the analysis using the CFD. And furthermore, to get that the result is, reliable. So we would like to conduct the experimental model test at Towing Tang. Okay, so now return back to, the presentation. So this, the outline. So we know that the conventional coastal protection, as we seen just now for the, fixed breakwaters, have some drawback, especially that if we are using the fixed breakwaters, so this will, effect to adjacent area of the fixed breakwater area. So what is the, negative effect? Mostly the surrounding of the construction fixed breakwater will get more worse erosion. So this actually happen nearby our campus. Because of that, we would like to provide the alternative solution by using the floating breakwater. However, the current floating breakwater also need to be more investigated comprehensively, especially the optimization modeling should be conducted. And as you may know here, we have already conducted the optimization modeling using the genetic algorithm. And finally, we would like to show the result and also the discussion on this presentation. So this, the example of the conventional breakwaters. So here we see that the rubber mount breakwaters, so already constructed in the deep water. As we see that the common storage protection system, especially the bottom fixed breakwater, either emergent or submerged type. So this will, vulnerable and suffer from the strong reflection. So this hard structure actually provide the negative effect to the surrounding environment, especially due to the strong reflection wave. And in the same time, so this also will amplify the wave energy to the surrounding. Maybe at the area protected by the fixed breakwater, so it's safe. But however, the surrounding or the junction of the that breakwater, so will be getting severe condition. In the same time, also this fixed breakwater has high cost construction. So this is the several type, can be groin, can be breakwater, can be seawall, can be the jetty. So this type of the fixed breakwater. As I thought just now, that the wrong design or the failure design of the fixed breakwaters will affect to the severe accretion and in the same time also severe erosion, as we can see in the slide. And since that the wave energy is considered 90% is dominated by the 3 times of the wave height at the surface. So meaning that the fixed breakwater is not compatible anymore. So meaning if we want to prevent the erosion for our coastal area, and we know already that 90% of the wave energy is, 3 times of the wave height. So it already sufficient if we develop the floating breakwaters. So this, some of the severe destruction erosion, yeah, caused by the fixed breakwater. We can see that it almost 1 or 2 years. So about 10 until 25 meters from the sea. So this getting worse, erosion. So this, the real example nearby our campus. So as well as the fixed breakwaters, so the floating breakwater can be an alternative solution. And the basic mechanism of the floating breakwater also similar with the fixed breakwater. So try to minimize the energy transmission coefficient and also try to minimize the wave reflection. And in the same time, also we try to maximize the energy wave dissipation. So this is the advantages that offering by the floating breakwaters. First is flexible, economical, lower conversion cost, and in the same time, less intercepting or reflecting all incoming wave and managing the return sediment transport in smoother manner. So meaning that the erosion is not getting more severe if we try to, design and develop the floating breakwater and in place. So the negative effect that caused by the fixed breakwater should not be happen if we want to replace with the floating breakwater. So in general, the floating breakwater can be divided into 2 categories. The first is the reflective structure, and the second is the dissipative structures. So we can see here. Can be box, can be Alaska, can be pontoon for the reflective, and for the dissipative can be mat, can be tethered floating breakwater, can be also cage. So, however, the issues the issues arising on the floating breakwater, especially unsatisfactory amount of the wave attenuation from the floating breakwater, especially in the long wave, is still being studied. So this, the key issues for the floating breakwater, meaning that if we develop one floating breakwater and dealing with the long wave, so the efficiency and the optimization result from the floating breakwater still in question. Moreover, that if you the existing design of floating breakwater dictates larger width dimension, meaning to say, if we want to block effectively the wave energy, we should develop the more width of the floating breakwater. And consequently, this width floating breakwater will also affect to the cost of the construction. So this need to be resolved. And a solution, we try to propose the twin pontoon floating breakwater that has been taking much attention by many researchers. Especially, we try to more minimize the wave energy transmission when the wave energy passing to the floating breakwater. So this, we can see that the transmission values of the floating breakwaters, and this is the current one. So with the ratio of the drop to the depth 0.4 and also width to the wavelength ratio 0.12, so we still get the coefficient of the transmission wave less than 0.5. What the meaning of the less than 0.5? When we obtain, the wave transmission coefficient less than 0.5, so meaning that the wave energy can be sufficiently reduced. As consequence, the erosion nearby the coastal area also can be minimized. However, if we can get more than 0.5, so meaning that our design will be better. And we would like to do so. So this, some of the optimization design regarding to the floating breakwater has been also conducted using the genetic algorithm. However, most of the research, most of the studies just conducted with the single objective, just to minimize the KT. However, in our design, we try to involve in multiple objectives, not only minimizing the KT, but also we try to minimize the KR. KR means that the reflection wave coefficient, and in the same time, we try to maximize the coefficient of the wave dissipation energy. And in this current design, most of the optimization is, validated by the potential theory. But in our case, we try to validate with the computational fluid dynamic approach, that the result will be more reliable. So this, the physical model of the floating big waters is like this. This one composing of the two ponton, and here is the cage. So this cage actually is porosity, just to reduce the wave energy below than the ponton, and in this ponton just to make that this platform is floating. Okay. So the floating big water usually the investigated using the potential theory. I think some of the drawback or weaknesses regarding to this approach, especially not involved with the irrotational motion and incompressible motion, and in the same time also the porosity, the viscous flow around the surface wave area also is not fully sufficient captured by the potential theory. Because of that, we need more comprehensive approach to obtain more reliable result. And in the same time, also insufficient literature that dynamic interaction between the floating big water and steam transport also is very less literature for the time being. And then regarding to the optimization dimension, the ratio of S over D, D over H, and the porosity itself is still unclear. So based on this, problem, we try to determine the optimum model of the twin ponton floating big waters. So here I propose application of the genetic algorithm. So the concept is we try to find the best genetic. From this best genetic, we would like to minimize the transmission coefficient of KT, maximize the loss coefficient of KR, and minimize the reflection coefficient of the KD. So this, the main purpose. So return back to the basic theory of the genetic of human being. So we try to find the best genetic that will be survive, and the bad genetic will be automatically killed. And finally, we produce only the best genetic that presented in the form of the optimum design of the twin ponton floating big water. So of course, it's like mutation also happened here, and finally we got the best genetic. So I think this, the flow chart of the optimization procedure on the genetic algorithm. So actually is a bit complex. So we are not only involving with the programming for genetic algorithm, but we also obtain the result in the initial stage from the CFD analysis result. And finally, also we try to validate again with the CFD. And after that, at the end of this studies, we would like to compare with the experimental model test result. So this, the mathematical model that involved in our analysis for the CFD. So this is using the Reynolds average Navier-Stokes. So, and also we try to involve with the dynamic equation for the floating object. So meaning that the wave excitation forces and also the moment inertia, respond from the structure also we capture here. So this, the objective function regarding to our approach. So this very important equation, especially this obtained by the, understanding the basic formula of how to minimize the KT and how to minimize the KR and how to maximize the KD. From the understanding, we try to bring in the physical meaning. So we got this equation. And of course, in the optimization modeling, we need a boundary limit and criteria here. So as shown in the equation 9 until 12. So this, the boundary condition of our modeling. Okay, so here actually we are not only optimizing the S over D ratio, the distance between two ponton, but also we try to optimize the ratio of the depth of floating big water itself. And in the same time, also we try to optimize the size of the mesh cage the porosity of the cage itself. So also this is very important, and involving this, three parameters actually is the complex matter, but luckily we obtain the good result from this modeling. So this, the actual model that we conducted in our modeling. Yeah. So the length of the pontoon is about 0.76 meter, and the width is 0.5, and the other properties is shown in the table. So this, the philosophy that why we should conduct optimization. We try to make a various lateral distance of the pontoon, and then we would like to find which one the optimum distance between these two pontoon. So this, the figure here showing us how to find the optimum S over D. And we involve here, including the porosity and also the ratio of the depth to the wave, to the wave height. So this, the CFD simulation approach, and also we conduct, as I mentioned in the beginning, also using the 2D analysis involving the potential theory, and we got here the result. Yeah, as we can see that, the CFD and also the experiment, yeah, is a better result compared to the numerical result. Yeah. So this, the validation that we conducted with some result from Jiangsu University, China, yeah, regarding to the SIM protein big waters analysis. Okay, and then this, the various KT, and also with respect to the wave period and also the wave height. Yeah. So we can see here that the reduction of the wave height is inversely proportional to the KT values, and noted here that the present optimization modeling on the TPFB model is based on wave height, since it was susceptible to the KT values. So that the wave height actually is fully nonlinear, so this will be inversely proportional with the KT values, meaning that the higher wave height, so the KT will be more or less. So this, also some result getting from the potential theory. Yeah, so we conduct the programming on the MATLAB. So this some the wave energy. Yeah, when the wave incident wave coming to the breakwater, so the energy wave dissipation is increasing, reduced. Yeah, especially when the wave, before passing the floating breakwaters. So I mentioned that the amount of the wave energy is proportional with the increase of the wave period, indicated by the vector of the blue color.
Prof. Ahmad,
So
you have 1 minute.
Okay, so I think this is some result, yeah, regarding to the wave transmission coefficient. Yeah, so like this. So this, the result from the genetic algorithm modeling. Yeah, so this the Pareto plan. Yeah. And then finally we obtain. So we would like to show you here the optimum one. Okay, so this, the extinct floating big water, we can see that the color yellow. The color yellow indicated that the velocity is very high. The wave velocity is high. But when we try to obtain the optimum distance between two pontoon, so the yellow color can be decreased and minimized, even can be demolished here, so become less wave velocity after passing the floating big water. This indicated that the erosion surrounding the area will be sufficiently reduced. Then also regarding to the wave energy, so we can see that the purple, the pink color is indicated the high wave energy, but when the wave passing the floating big water with the optimum design of the floating big water, so the wave energy also can be reduced. So ini also some of the wave dissipation energy also same, yeah. When passing the optimum one, so the wave dissipation energy coefficient also increasing. So I think this is the interaction of the floating big waters. So just reanimate again, just a moment. So actually in the down side there is a sand, and then we can see that the sand is created at the coastal zone here. So I mean that this suspended sediment transport and also the suspect sediment characteristic will be opposite result. Okay, and then continue. This I mean some bed load. Yeah, if we want to discuss more in detail on the bed load and also sediment suspended sediment transport. Yeah, coefficient. So like this. So I think this also we can see that the comparison between the existing the floating weak water and the optimum. So the sediment transport here can be reduced. Yeah, indicated by the red color. Here the existing one, and here is the optimum one, meaning that the amount of the erosion, yeah, at the coastal can be reduced. So I think this is the conclusion that the multi-objective optimization model using the genetic algorithm has been successfully developed toward the optimum hydrodynamic performance of the TPFB, and the optimum TPFB here stated that the SD is 2.5. D over H is 0.4, and porosity here, the optimum one is 0.5567, result in decrease of the KR, yeah, and also increasing the KD up to 0.9 compared to the existing one that the KD is less than 0.3. So it's totally different. Meanwhile, KT reduced from 0.5 to less than 0.3. This I think is good result compared to the existing one, meaning that more or less of the KT will be more or less the web transmission energy reduced. So the last one, the optimum twin pontoon prolific water reduce the gradient of the bed load and suspended sediment concentration within the range 200 up to 400% for the short web and 5 up to 30% for the long web. So I think this, I mean, the good result, a good finding regarding to our development of the optimum floating big water. So this I mean just acknowledgement that this actually research is funded by a transnational research grant scheme, so up to 200,000 US dollar, equivalent to the 900,000 ringgit. Okay, I think thank you very much for your attention and sorry for the delaying the time. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Ahmad, for your very interesting presentation. We still have several minutes, probably around 2 minutes for discussion. To all the audience who follow this presentation, I invite you to give question to Prof. Ahmad. Okay. If no question, I think I have just a little bit question. Prof.
Yes,
Ahmad,
please.
normally in coastal engineering, when we talking about the breakwater, we talk about the refraction coefficient. Is it similar with your coefficient in this your study?
Yes,
Because,
it's similar. I mean, normally the reflection coefficient for the fixed brick water is high, but if we employ the floating brick water, so we can reduce the web reflection coefficient. And as I saw in the slide that due to the construction of the existing brick water, considered the fixed brick water, so the strong reflection happen, and then finally the surrounding of, I mean, the fixed brick water is, so meaning that some of the drawback from the fixed brick water, so is high web reflection.
Okay.
Yeah.
I think there will be a question from Mr. Didit. Yeah, Mr. Didit. Mr. Didit, not yet. Unmute.
Yeah.
Widianto.
So Dr. Bekti also is coastal engineering?
Yeah, I in consultancy from mainly in hydrodynamics, shallow water, yes.
Shallow water.
Yes.
Yeah, I
Okay.
think should be has a similar content also with my presentation.
Okay. Okay. Quite similar, I think.
Yeah, yeah.
But we should quite. I think the GFD is quite different. We normally use long wave, tight wave, not short wave like your presentation.
But my web length also is, I mean up to about maybe what we say 8 second 9 second of the web period, so meaning that also considering the long web.
Okay. Yeah, yeah.
So we are here using the CFD flow 3D. Maybe Dr. Bekti heard also flow 3D.
Flow 3D. Oh
Yes.
no, no. I normally use
Mic 21.
Yeah, like Mic 21 or
Yeah.
Dev 3D, something like
Dev
that.
3D.
Yes.
So yes, but actually for the Mic 21 is for the long period prediction, isn't it? So my prediction is only for the real time prediction, not consider for 10
Okay.
years, not consider for 20 years, just only for the current condition.
Okay.
So,
Okay. Mr. Didit, if you have question, I will unmute you, but it is for the technical civil Bakri, right, Mr. Didit?
Yeah, I'm sorry.
Okay.
I'm using the Zoom link
Okay.
for access from my university's Universitas Bakri. I'd like to raise one question about the effect the energy generated by your testing, Pak Ahmad Fitriadi, in your testing area. How much energy can be extracted from your model? For example, 500 watts to or more or something.
I mean, regarding to the energy, web energy, something like that. I mean, renewable
Web
energy.
Yes. Yes.
Okay, thank you, Mr. Didit, for the question. Yeah, sorry to say I cannot answer your question because my presentation is about how to protect the shoreline from the web energy destruction. So dealing with the polluting water.
Okay.
So sorry, I cannot answer. But as far as I know, that the web energy, feasibility, especially in Malaysia, so it's not much promising. Yeah, because especially at the west coast, nearby to Selat Melaka, so the web height is very less. Yeah, and the potential one actually nearby to the east coast of Malaysia. I mean, bordering with the South Chinese Sea. However, as far as I know from my colleague here, the potential of energy to be harvested at that sea actually is also not promising, except 10 kilometers from the shoreline.
Oh, okay.
Yeah, 10 kilometer dealing also with the how to transmit to transmit the energy to the land also is a big problem.
Yeah.
Yeah.
Okay, Master.
Okay. Thank you, Pak Didit, for your question.
Oke. Terima kasih Pak
Pur.
Dr. Bekti. Terima kasih banyak
Ya,
dan mohon maaf ya.
Oke. Terima kasih Pak Prof. Ahmad. I think we already because of time limitation, we cannot continue our discussion. So thank you very much to Prof. Ahmad for
You're welcome. You are welcome.
Yeah, very interesting presentation today. I think we can continue to our parallel session. I will invite Mr. Trayonggo or Mr. Ramdhani or Mr. Didit, I think it is. The title of the presentation will be Anak Krakatau Landslide Tsunami relates potential hazard. I'm sorry. The second presentation is Syafiqoh Rahmania of Mr. Danar and Mr. Rohmaneo Darminto. The title is about identification of jetty ruins on the seabed using sub-bottom profiler and side scan sonar. This dedicated special port of PT Holcim Tulpan. Ms. Syafiqoh, are you ready to presentation? Syafiqoh Rahmania or Danar Guru Pratomo and Rohmaneo Darminto. I think they are not joined this room yet, so I invite the next presentation is Mr. Trayonggo Ramdhani and Budianto Ontowiryo. Pak Didit, anak Krakatau landslide tsunami relates potential hazard. One of the author can presentation their paper. Mr. Trayonggo, Danar, oh Pak Didit probably. Silvianita. Oh ya, Pak Didit belum di-mute, di-unmute. Unmute.
Thank you. I'm sorry.
Okay.
I'm trying to, I will start my presentations. Can I share my PowerPoint? Okay, that is good. Okay, let me start with my PowerPoints. Thank you very much everyone to accepting us to present our presentation. Assalamualaikum warahmatullahi wabarakatuh. Today our presentations will be brief, but it's related to a few important points. My students Adeputra Trianggoro, as well as Pak Andri Ramdhani from BMKG and myself, Budianto Ontowiryo, will present the Anak Krakatau landslide tsunami relapse potential hazards. The outline of the presentation is what lesson learned we have learned from 1883 eruptions and Anak Krakatau eruption that generate tsunamis in 2018, and how the new bathymetric data are collected and in the numerical model for the future Anak Krakatau volcanic activity, potentially tsunamis may be generated by these new bathymetric data, and what kind of measurements technology that we can use to measure the wave signature from these silent tsunamis that may be generated by the volcanic activities. And we will conclude some of the presentations of our presentation, what we learned from this new data that we have been collected. I'm sorry, a second. how do I really like to start my presentation. Okay. What we learned from Anak Krakatau landslides 2018, and the previous one was in the what would be the idea of having these simulations in 2012 and happens in 2018? That is very early than we are expecting to happen. Previously, we think the landslide would occur like 10 or no, 10, 20 or 30 years after the 2012. But then it happens earlier. What is happening in there, and how we measure it, how we adjust the measurements, from the measurements, the new model for the future potential tsunamis. This is the things that we have. Even myself, when I heard the silent tsunami happening, I thought it was only a high tide, very high tide, and then it appears that become a tsunami later. And I was asked by others researchers, this is your papers in 2012. I already forgot it. So then what we learned from this Dr. Heri Haryono and Christine De Plus measurements, this is the most important, that the caldera, the Anak Krakatau, sits on the brinks, on the ring, on the steep slope of the caldera 1883 Krakatau eruptions. That implies the potentials can be reoccurrence, can be relapse, can happen again if the activities accumulating materials, and the materials reach the same height, then the height is enough to become a landslide again. But fortunately, we have a shallower area, as we can conclude from our bathymetrics surveys. Later I will explain. Fortunately, we have that conditions, but not yet safe. That's his potential is still there. So I can show you, this is understanding the 1883 Krakatau complex, whereas the Rakata, Danan, and Perbuatan Vent now become Anak Krakatau. This is the area that is landslide. This we already know, so I would fast forward it. And as we know, the speed from 1928 to 1959, the ring basic andesite of Anak Krakatau was constructed. Was growth rates in 30 years to 150 meters. That means about how much? About more than 10 meters. More than 10 meters a year. About 30 meters. Is it 5? Yeah, it's average 5 to 10 meters per year. That means that if it's happening again, it will continue again with the same rate. We will see the now it's lowland area with the inner lake. It will become the same height as the surroundings in maybe in 10 years. So the potential of eruptions affecting, then generating landslide again is still there. What if the growing keep continues? We would like to see it in our presentations. Okay, this is the simulations that shows the extensions of the debris. If we see the what is the brown area here, the materials that become resides on the sea floor, and it estimated from our study in 2012 is 0.26 kilometers square or 280 million meters cubics, meter cubes, not kilometer cubes, not kilometer square, kilometer cubes. And also Greeley try to estimate 0.27 kilometer cubes, as well as Abdul Muhari is 0.21 kilometer cubes. And according to bathymetric survey change, these landslide materials by Deftapin groups, it's 0.19 kilometer cubes, and Posidro is about the same, 0.19 groups. So the important part's not only what kind of materials that generate tsunamis, but also the material landslide. Is it low density or heavy density landslide? This is also important. If we think like a Batu Apung as everything, or it could be more basaltic rock, big rocks, or it's more on the pyroclastic accumulations materials. This is the models we generated in 2012, and the results and the crossings, which is indicated by paper of Hari Harjono and the Plus, and this is the rheology or densities differences. We tested it, and this is also tested it with the flow 3Ds. We see the effect of the neighboring islands, in this case of Sertung Islands, on this website, on the west side, receiving the big wave from the landslide. This is with low density materials, about 1,600 kilograms per meter cubic densities. I am testing with more heavier materials, and it generates more wave, bigger wave. So it is important of the understanding this 3D models with the flow 3Ds that Ahmad Fitriani mentions. It will give more realistic and understandings of what affecting a run up on the islands, surrounding islands. And this is our simulation before. This is during the Boxing Days, during the night of, and then the following days when the landslides occurs. And this is the present landscape of the Anak Krakatau. We would expect a fast growing of Anak Krakatau from the same vent, perbuatan vent, in the upcoming years. We hope that hopefully not in the 10 years, but if it happens early, then as early as 10 years, we could see the growing of cone, Anak Krakatau will reach the same height as the present height, as this picture's present height. This is the loss of materials that can be seen from the above. On the right side, we see almost similar features from this and this. We see how much the left missing, and this is Prof. Deftapin surveys, as well as Posidro's survey data that indicates a big chunk of materials that can be distributed around this deep floor of Anak Krakatau. As we can see, the blue elevations, it remains minus 270 or 250, 270s. This is still a deep area, and this is surrounding it. The big chunk is remnant of remainings of the previously caldera collapse, not from the Anak Krakatau collapse. From these informations, we can extract it. So it's still a potentially there, but fortunately we have a lower, shallower area when it will be collapsed in the future. But we don't know how the materials is accumulating. So this is a description of what Prof. Deftapin mentions. The debris field runs out of about 2 kilometers from this area. So this is about this area, but still we still see the deeper part of the caldera is still there. So potential is there. And this is when the survey area indicate this is the impacts of contacted on an Sertung area, which reach about 72 to 80 meters run up. This is there. We can see it, how the run ups washing the shoreline of Sertung area, Sertung islands. This is a survey that we have done. It's comparisons. And the more important questions would be, what would be the measurement device that we can use to have it served 24/7 times, even when we are asleep, but it's still detecting the potential of either volcanic activity or megathrust activities. I would suggest this over the Horizon FMCW phase array radar that has been installed in this area, that maybe can be useful. We can see here's the result from the Tanjung Lesung area and Kahai area. This information is given by Pak Andri Ramdhani from BMKGs. These systems, I think, is quite good. If we see inside the red red circle area, we can see some of the wave reaching the Krakatau complex. Maybe in the activities of Anak Krakatau, we could detect some of the wave coming, or wave currents, or whatever signatures that might be possibly potentially generate some of the hazard to the coastlines along the Banten's Pesisir Sunda Straits and Lampung. And this is my conclusions.
Only have 1 minute.
Okay, this is my conclusions. So we have still these potentials. In 15 to 20 years, we might have some enough materials to collapse. And from the bathymetrics map, Mas, bentar, aku lagi presentasi. Bentar ya. Aku lagi presentasi. Bentar aja. Nah, and the bathymetrics, this is from my other students. He's waiting in other rooms. I'm sorry. He's already calling.
Okay.
That should be all right. So from the new bathymetric maps, we know that the depth of the caldera is still there. We still not in a safe place. It's still a potential. We need to make some new calculations. We need to make some models. It's a 3D or 2D would be sufficient to identify it and publish it. We would like anybody to know about this potential might occurs in December 2018. And also the importance of the measurement device that now installed by the MKG, but then also it has to be added by pressure gauges and whatever means of networks that is important to identify volcanic activities that might generate tsunamis. And this idea was compiled by many of sources that I would deeply appreciate all the efforts to make these publications conclusion research is possible. Thank you very much. That's conclude my presentations.
Okay, thank you, Pak Didit, for very
you.
interesting presentation. I invite you all. If you have any question, you can
all right
directly raise your hand or from the chat room.
May I ask question, Dr. Bekti?
Okay.
Yes,
okay,
yes.
Pak Ahmad.
Yeah.
You're welcome.
So very nice presentation from Dr. Didit. I mean, from Dr. Budianto. So especially on the 4TD simulation. So in your 4TD simulation, So what do you simulate? I mean, do you also include the landslide simulation modeling on your research?
Yes, yes, but thank you, Pak Ahmad, for the good questions. I did simulate the two-phase flow with the different densities. I tested it for rho higher than one, about the rho of the pyroclastics potential flows, as well as heavier rocks potential flow to from 1600 to 2200 kilograms per meter square of densities.
So, do you include, I mean, the landslide modeling in your research?
Yes, there's a landslide modeling.
Oh,
It's a landslide modeling.
Yeah, because
But
I
this very interesting. Model that we can explore. We could do collaboration simulations related to
Salah.
tsunami. That's very interesting. Thank
Yeah,
you.
so we have a 6 license for the Proti this year.
All
So
right, that's
we
great.
can join with you later on.
Great.
Okay, thank you,
Very
thank you.
powerful.
Salah. Okay, thank you, Dr. Didit. Okay, terima kasih.
Arigato.
Okay. Thank you, Pak Didit, and also for long time no see.
Ya kabur, kita main badminton lagi.
Iya, kapan-kapan.
Kalau udah lewat pada COVID-nya ya.
Betul, betul. Oke, terima kasih.
Thanks, Bapak.
Because of time limitation, we cannot continue our discussion.
Alright,
And
okay, thank you. So
we
I
continue.
left to other
Okay.
rooms because my
Okay.
other students are waiting. Terima kasih Pak Pur, Pak
Oh,
Ahmad, and
yeah.
everybody. Please stay healthy for everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Warahmatullahi
wabarakatuh.
wabarakatuh.
Okay, I invite the next presenter is if Ms. Saifuko already joined this room, you can present your paper. Saifiko, Rahmania, or Mr. Danar, Guru Pratomo, or Mr. Rohmanio Darminto. Okay, if they are not join our room, so I invite the next presentation is from Mr. Suroso, Amalia Dwi Wahyuni, about the prediction of stream flow at the Pemali catchment area using Cetran model. So Amalia, are you ready to presentation?
Yes, sir.
Yes.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Thank you for the chance that given to me. First, let me introduce myself. My name is Amelia Diwayuni, a senior student from Jenderal Sudirman University, Purwokerto. In this opportunity, I would like to present about prediction of stream flow at the Pemali catchment area using Cetran model. An outline of this presentation contains introduction, objective, studio location and data, the method that we use, result and discussion, and then conclusion. For introduction, there's a lot of natural disaster in Indonesia since 1918, such as flood, earthquake, drought, and many more. According to BNPB, flood is the most frequent natural disaster with 9,053 events since 1918 to 2019. For this half year, there were 441 floods, and the most flood happened in the central Java with more than 150 floods. The Pemali River Basin is one of the watersheds located in the north of the island of Java, and this is part of the Central Java province. The area covering the Pamali River Basin is Brebes Regency and part of Tegal Regency. In Brebes, the number of missing or dead victims because flood was 13 people, and the number of affected victims was more than 20,000 people. Whereas in Tegal, 40 flood events occur annually from 2003 to 2019. The number of missing and dead victims was 10, and a total of 4,354 people had to be evacuated. As an effort to prevent and warn of flood hazard, remote sensing derived dataset can be a facility. One method used in the use of remote sensing technology with the hydrological model is the SETRAN method. This study aimed to determine the stream flow of the Pamali River during the period of 2001 to 2017 and expected to help in reducing flood risks. The Pamali watershed is one of the watersheds located in Central Java. Most of the Pamali River Basin, covering the Brebes and the Tegal Regency. It's bordered by Banyumas and Cilacap Regency in the south, in the west by West Java, and in the east by Tegal City. Data used in this study are mostly obtained from satellite observation, such as digital elevation model or DAM. The DAM are collected from the Shuttle Radar Topography Mission or SRTM. The digital elevation model is a computer representation of the Earth's surface. It provides a basic data set from which topographic parameter can be generated digitally. Then land use land cover or LULC. LULC is land use data derived from MODIS. The MODIS use class is then grouped based on the SETRAN class, which consists of arable, background, grass, deciduous forest, evergreen forest, shrub, and urban. And the data observed in this research from 2001 to 2017. And then the Harmonization World Soil Database or HWSD. HWSD is a map of the distribution of soil type in the world created by the Food and Agriculture Organization and the International Institute for Applied System Analysis by combining regional and national land map. And then Tropical Rainfall Measuring Mission or TRMM. TRMM satellites are satellites developed to measure rainfall in the tropical area like Indonesia. And the TRMM Precipitation Radar or PR is the first spaceborne rain radar and the only instrument on TRMM that can directly observe vertical distribution of rain. And this study data observed from 2001 to 2017. And then evaporation. The evaporation data in this study come from the Global and Land Evaporation Abstract Model or GLAM. GLAM is a set of algorithms dedicated to the estimation of terrestrial evaporation and root zone soil moisture from satellite data. In this study, evaporation data set measured from 2001 to 2017 are used. The method used in this study is the SETRAN hydrological model, where the input are collected from satellite measurement. The remote sense data set include DAM, LULC, HWSD, and TRMM processing by using ArcGIS to produce ISOCEEN data. On the other hand, the grid code from the TRMM raster data and evaporation processing using Excel to produce CSV data. The ISOCEEN and CSV data is then written to the XML file and then running the data using SETRAN easy setup and the standard version. After running the data, we will get the output from SETRAN as daily outlet discharge. For the result of the study, it's found that the SETRAN model is generally able to capture the flow characteristic of seasonal river flow. The results show that the beginning and the end of the year is rainy season. Meanwhile, the middle of the year is dry season, which is marked by low rainfall. This is graph for the daily outlet discharge in 2017. And then for the maximum daily discharge pattern in a year or flood discharge. The result of SETRAN work have a stable but fluctuating trend. Meanwhile, the maximum discharge at outlet generally occur in wet months, such as January and December. To find out whether SETRAN is good enough to be used to predict river flow is to compare the result with the discharge measurement in the field. We're using data from Brebes Station, which is the closest station to the downstream area. From the graph, we know that the result from the SETRAN output tend to be similar to the field data in 2010. The measurement of monthly discharge was fluctuating and tended to be stable. Likewise, the result of SETRAN output in 2010 also tended to be fluctuating and stable. For 2011 and 12, the recorded measured discharge has a small value in the dry month. Meanwhile, for the 2011 and 12, the SETRAN result also has small value in dry month. With this ease of predicting flow rate, SETRAN has the potential to be used as an effort to mitigate flood disaster. And finally, from the conclusion of this study are, the daily discharge from SETRAN modeling is generally able to mimic the characteristic of seasonal rainfall, like rainy season and dry season. And then the maximum daily discharge that has the potential for flood disaster mostly occur in the wet month, like October to April, which usually occur as well. The monthly mean discharge from the SETRAN simulation result is similar to the measurement result. And there is a potential use of SETRAN model for flood disaster mitigation. Thanks for your attention.
Okay, thank you, Amalia, for your presentation. I invite all the audience, if you have any question, you can deliver to us. Maybe a little bit question from me. Amalia, if you make a simulation of inundation, I mean genangan, have you made simulation and how about the result? Simulation.
The simulation or inundation?
Yeah, inundation, genangan banjir. Have you make simulation using SETRAN?
Oh, yes, sir.
What about the result? Yeah.
The result kinda gimana ya ngomongnya?
Belum bisa di ini ya.
Maksudnya waktu gimana, Pak?
Ya, itu hasil dari genangannya apakah sudah bisa memprediksi ini daerah rawan banjir apa tidak, seperti itu.
Oh, untuk hasil genangannya sendiri ada, Pak. Cuma kalau misalnya per daerahnya belum bisa.
Belum ini ya, per grade.
Per titiknya belum.
Oke, mungkin itu menjadi PR berikutnya ya barangkali. Oke, terima kasih. Thank you, Amalia, for your very interesting presentation.
Okay, thank you.
I will invite the next presenter is Isaac. Are you ready, Isaac? Isaac Aksa Gifari. The title of presentation is Detection of Trend Behavior of Extreme Rainfall over Java using Man-Kendall. Okay, Isaac. Unmute dulu ya.
Yes, Jack. Can you hear me?
Okay. I can hear you. So you can begin your presentation.
Yes, thank you. I was sharing the Can you see the PowerPoint? Let me check. Ya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. It's a pleasure for us to be able to think research in 2020. So the title of our is Detection of Trend Behavior of Extreme Rainfall over Java using Mann-Kendall test. So this is from Department of Engineering at University of General. Overview in the matter will divide the presentation into four parts. First is introduction, after that data and study location, followed by method, and we have result introduction. So introduction, the background of our research is we are inspired by flood disaster.
I think Isaac has problem with connection. Isaac, I think he has problem with connection. So we can postpone his presentation probably later after he join again. We can continue his presentation. The next presenter is ready. I will invite Ms. LS Palupi. Can you, are you ready? Okay. So because the last presenter is not ready for the connection problem, so you can present your paper. Ms. Listiati.
Pak Purwanto.
Yeah. Okay, I can hear you.
Should I start the presentation now?
Yes, you have 10 minutes for presentation.
All right. So this will be my first presentation, my first paper. Can everyone see my slide?
Yes, we
Okay,
can.
okay.
Sorry, I have a technical problem. Oh, right. Good afternoon, ladies and gentlemen. My name is Livia Tisyopalusi. I'm a lecturer at Fakultas Psikologi, Universitas Airlangga. Now, today I would like to share my research entitled, "Is there any gender difference on psychological preparedness for potential disasters of university students?" This research is part of a large project on psychological preparedness for disaster study that made possible by the fund granted by Indonesian Ministry of Research and Technology or National Agency for Research and Innovation or RISC. The outline of my presentation today will be divided into two sections, which will include introduction, method, result, and discussion. Let's move to the introduction. As well as we all know that today the COVID-19 pandemic is still active and affecting countries all over the world. The COVID-19 pandemic was acknowledged as a global disaster that not only affected the underdeveloped, but also developing countries. In Indonesia, during a 1 month period from August 2020 to September 2020, the number of both the confirmed case and deaths were growing significantly, up to about 80%, with 207,203 confirmed cases and 8,456 of deaths. The significant rapid increase in number of COVID-19 cases has made the government apply policy to reduce the cases. One of the policies that implied is the large-scale social restriction policy. It has been reported in several studies that this pandemic has been a significant impact not only to the economic and social aspects, but also psychological or mental health conditions. It is reported that strategy employed by the government to reduce and stop the spread of COVID-19 has brought several psychological problems to emerge. Current study found that the pandemic has increased negative affect, anxiety, and depression among the university students. It also said that the negative impact of these COVID-19 pandemic disasters could also seen months or years after the disasters. Therefore, it is important to prepare the community, especially the university students, to cope with the situation in order to reduce the negative impact that could emerge further in the future. Research has found that psychologically preparing individuals for a disaster could potentially decrease the psychological impact of disasters. Therefore, it is important to psychologically prepare the university students to reduce the impact of the COVID-19 pandemic. Previous studies found that there are several factors that influence psychological preparedness for disasters. However, the role of gender, especially in psychological preparedness for potential disasters among university students in the context of COVID-19 pandemic, has not yet investigated. Therefore, the aim of this study is to identify the relationship between gender and psychological preparedness for potential disasters among university students in the COVID-19 pandemic context. So next, I would like to discuss the psychological preparedness for potential disasters concept. The psychological preparedness for potential disasters was drawn from the disaster preparedness concept. According to Freeman, disaster preparedness is the state of readiness to deal with a disaster if and when it occurs. According to International Federation of Red Cross and Red Crescent Societies, it is a measure taken to prepare for and reduce the effect of disaster That is to predict and where possible prevent disaster, mitigate their impact on vulnerable population, and respond to and effectively cope with their consequences. From the disaster preparedness concept, we learned that individual needs to not only be prepared, but also cope to the impact of disaster. Studies suggest that psychologically preparing individuals for a disaster could potentially decrease the psychological impact of disaster and promote resilience in the long term. So next will be psychological preparedness for potential disasters. There are several authors that define psychological preparedness for disaster. Morrissey and Rester have defined it as a process and capacity such as knowledge, consent, anticipation, recognition, arousal, thinking, feeling, and action. While now define psychological preparedness as a heightened state of awareness, anticipation, and readiness for the uncertainty and emotional arousal in expectation of the possible occurrence of the threat, and one on psychological response to the unfolding threat situation, and the ability to manage the demand of the situation. Draw from the previous study, psychological preparedness for potential disaster in this study is defined as using ABC attitude model, defined as a person attitude towards disaster that could be predicted in terms of affection. This is how a person emotional reaction towards disaster, and cognition, which is knowledge and belief that a person has towards disaster, and a person anticipation behavior to reduce the risk of disaster. We also found that there are several factors that influence disaster preparedness, such as gender, age, socioeconomic, and education. The next section is method. In this research, the method we use is survey research, and the participants involved in this study was 383 university students. Our respondents should complete psychological preparedness for potential disaster scale, which consists of 3 parts. The first part of the scale was provided to record participant informed consent. The second part is a part where participants fill their identity. And the third part is the psychological preparedness for potential disaster scale. This scale consists of 71 item version, which include 35 items of affective dimension, 13 items of behavior dimension, and 23 items of cognitive dimension. The internal consistency of the scale was using alpha Cronbach, which is a 0.796, which considered as a reliable scale. A chi-square test was used to determine the relationship between gender and psychological preparedness for university students, and the analysis were carried out by using the SPSS version 26. Next, I will be presenting the finding of this study. First, I would like to describe the demographic profile of the participant based on the gender, and next, the participant profile of psychological preparedness for potential disaster based on gender, and the last one is the relationship between gender and psychological preparedness for potential disaster. Okay. From the pie chart, we can see that 80% of the participants is female and 20% is male. Now let's move to the participant psychological preparedness for potential disaster profile. From the pie chart, we could see that most of the participants will lay in average level of psychological preparedness for potential disaster, which is 90% of the total population, where 6% were in low and 4% of them in high level of psychological preparedness for potential disaster. Move to the next one. which is the abbreviation for the psychological preparedness for potential disasters is PPPD. We can see from the pie chart here. On the right hand side, we could see from the chart that 89% of female participants were in average level, and then 7 and 4% were respectively in low and high level of psychological preparedness for disaster. While on the left hand side of the pie chart, we could see that 95% of male participants were in average level, while 1 and 4% were respectively in low and high level. So based on gender, we could see from both of the pie chart that the majority of male and female participants were in average level of psychological preparedness for potential disaster. Move to the next one, which is the hypothetical testing. Oh, sorry. This one. Okay. A person-child square test was carried out to assess whether gender and psychological preparedness for potential disaster is related. And the analysis showed that there is no statistically significant association between gender and psychological preparedness for potential disaster, which is since that from the p-value that is larger from the p hypothetical
Ms. Palupi, your time.
Move to the next one. Yeah. From the analysis, we could see that first, the psychological preparedness for potential disasters of the majority of the university students were in average level. Males and females equally were in average level of psychological prepared for potential disaster, in meaning that most of them were not feeling anger with the disaster, have sufficient knowledge of the disasters, and try to anticipate the disaster by preparing the basic things such as food and medicine that might help them to survive from disaster. The second finding is that psychological preparedness for potential disasters among university students was not affected by gender. This is actually in line with previous study that conducted by Morrissey and Resser in their study on the effectiveness of psychological preparedness advice in community cyclone preparedness materials. In this study, they conclude that the demographic variable explored is not significantly related with psychological preparedness. Research in the field of disaster preparedness conducted by Najati and colleagues on demographic determinant of disaster preparedness behavior among Iranians also found that the relationship between gender and disaster preparedness behavior was insignificant. This is due to an equality between men and women in making the same decision in disaster preparedness activity. This also became the case in Indonesia, where both of male and female were involved in mitigation and preparedness activity. Also, in case of women, the activity were centered inside the house. However, further research on psychological preparedness for disaster among university students should be elaborated further using qualitative research methods in order to have deep understanding on the cause of insignificant difference between gender and psychological preparedness for potential disasters, as well as other determinants. Okay, thank you for listening.
Okay, thank you.
I will give back to the moderator.
Yeah, okay, for your presentation. I invite the audience, if you have any question, you can deliver to Ms. Palupi. No question. I a little bit curious about how do you classify the preparedness, because you classify it into low, medium, and and high awareness, right? I'm sorry, I didn't see how do you classify it. Miss Palupi, do you
Yes.
about how you make classification of
On
low,
what?
medium and high preparedness, because I didn't see how you classify into low, medium, and high preparedness.
Okay. All right. Thank you very much for the question, Mr. Purwanto. Pak Purwanto. Uh, I classified the categories of psychological preparedness for potential disaster based on the response of the participants when they fill the questionnaire. The psychological preparedness for potential disaster questionnaire, which consists of 71 items.
Okay.
Yeah, from that, and then we calculate and then categorize from the score. We categorize them into high, low, and average level of PPPD.
Okay.
Thank you.
Okay, thank you, Ms. Palupi, for your answer. So, also for very interesting presentation. I will, because of time limitation, I should go to the next presentation. I think Mr. Isaac already joined again our room. So, Isaac, are you ready for your presentation? I think he is not ready yet, so we can go to the next presentation from Mr. Danar G. Pratomo, Komsin, and Mr. Herlambang about the identification of free span on underwater pipeline using side scan sonar and dual head scanning profiler. Mr. Danar, are you ready for presentation? Danar G. Pratomo, Komsin, and Mr. Herlambang. I think they are not available also. So I invite the next presentation from Miss Melanie Quintania, Mr. Dani Fatur Rahman, Mr. Hussain Bayu Pasupati, and Ahmad Taufik about utilization of GPS technology in the maritime sector on motor sailing yachts. Miss Melanie Fatur Rahman, Hussain Bayu Pasupati. Melanie, I think he joined this room.
Yes.
Okay.
Mute my speaker.
Okay. You can begin your presentation. You for 10 minutes from now.
So screen share, please.
Okay. You can share your screen.
Not yet.
Would you please allow us to screen share?
Mohon maaf Pak Bakti, ini untuk giliran selanjutnya bukan Melani Pak, tapi Melisa Menendez. Iya.
Melisa.
Iya Pak, maaf ya Pak.
Presentasi nomor berapa? Nomor
8 Pak sekarang.
Nomor 8 itu yang bukan Melani ya?
Bukan Pak. Iya.
Judulnya yang ident 1 2 3 4. Yang utilization of beda orang berarti ya?
No, that is my paper, Pak.
Iya itu Bu Melani ya, benar ya? Terus iya. Terus yang Melisa itu yang mana ini papernya? Bukan ya, nggak ada yang namanya Melisa di sini. There is no presentation for Melisa in my list. So for Miss Melanie, I think you can continue to.
Would you please turn on the screen share?
Screen share. Melanie. Nggak ada tombol screen share. Share.
I can.
Bisa screen share ya, Bu Melanie?
Yes.
Panitia bisa membantu Bu Melanie?
For Miss Melanie, can you try? Okay.
Yes.
Okay.
I'm delighted and happy to be here sharing with you my paper titled Utilization of GPS Technology in the Maritime Sector on Motor Sailing Yacht. Global Positioning System, a technology that broadcasts radio signals by utilizing dozens of satellites orbited as the access point, operated initially by U.S. government. The presence of this technology eliminates several problems faced by business people, especially in increasing innovation and competitive advantage to win the market. This transportation becomes a unified national transportation system to maintain one unity of Indonesian maritime affairs. According to JICA final reports in technical presentation, since the end of the 20th century until now, the shipping fleets on motor sailing yachts in Indonesia have experienced difficulties obtaining cargo because other vessels have used much better technology, so that the volume of freight in quantity has significantly reduced. Utilization of technology only has the aim of being fast, precise, and accurate in each implementation, and able to find a better solution at a time in several sectors. For example, an integrated navigation system for the visual impaired and disabled by navigating based on static and dynamic data using Global Positioning System or GPS. Especially in maritime sector, the concept of this fleet uses a heat and oil combustion engine system as a wind power tool needed by the community to reduce fuel oil by up to 50%. The optimal route method, computation through multi-objective genetic algorithm, to provide a decision helping tool giving the route. that minimize the fuel consumption in a limited or optimum time. Implementation of automatic identification system, which is integrated with navigation devices regarding data interpretation and error recognition through GPS, AGIS, VTR, radar, and ALPA tools, which require a sailor to use this device and function this system properly. Several examples of the application of technology in the maritime field indicate that technology has a user-friendly concept that supports users to identify, process, and even make decisions. And therefore, it is essential to use a GPS tracking type application to monitor the position of the activity and the ship presence at an ordinate point. The study aims to identify the use of GPS technology to track the position of the motor sailing yacht, specifically with a feature used on a device or smartphone during a trip or expedition. GPS technology uses an unusual information system approach, namely the Geographic Information System, or GIS. GIS is a computer system that can build, manage, view, store, and geographically reference information. For example, data identified by location in database, such as Global Positioning System, or GPS. GPS uses a global navigation satellite system for determination of location, speed, direction, and time, which has been fully operational in the world until now. GPS technology can be used for land, air, or sea transportation, which function to find out information or the whereabouts of an object or position, analyze ship performance, safety factors, and others. Motor sailing yacht, in its operational activities, is one of the subsystems of the national sea transportation system, which is a traditional shipping business. The middle economy class generally manage the shipping business of the people, and the executor is none other than the indigenous people. The advantage of this shipping still accommodate the expedition of production capacity of around 19 to 20 tons of cargo per GRT per year are as follows. Repairs, maintenance, and supply spare parts, so do not depend much on imported materials. The operation is not to depend on the port infrastructure of origin and destination, is self-sufficient and not overly bound by strict safety rules, and there are no route rules. The data and methodology. The research uses a type of applied research to solve problems that are faced clearly, and the result can be used as a basis for solving corrective steps. Data collection begins with reading literature, electronic media, website of GPS service providers, and some other data and information, then continues with field observation. The study begins by discussing the general description of the pelayaran rakyat business, which includes the condition of the fleet, the flow of cargo, the facility used to analyze the problems that occur. After that, they are followed by key informant interviews, namely ship owners and crew vessels, specifically for technology that has not been and has been used. The results are expected to design the application of GPS technology to maximize it so the user can get fast, precise, and accurate information. Result and discussion. The use of transportation with a motor sailing yacht in Indonesia, or known as the pelayaran rakyat. Users of this type of ship are classified as a land retainer in general, as ship owners, as operational executors land, related to the production of transportation services, both in handling goods, finance, sharing of business results, and goods needed by the crew. In contrast, the maroon retainer is fully responsible for shipping both in ship technicalities, the safety of the ship and crew, and this voyage connect the feeder port between regional and local. Loading and unloading are carried out using a small-scale transportation system, particularly the transportations of 9 essential commodities, building materials, and fertilizers. This technology contains at least component fees, startup and reference system, foundation and position and compass calibrate, setting waypoint, creating and tracking route, and else navigating to a terminus for navigation activities. And furthermore, web processing technology can be developed to support tracking and navigation activities, including storing large text or data, reporting processes, electronic document approval processes, and so on. Based on the mathematical calculation and the receiver's navigation word system above, this technology can be adopted with the design of a motor sailing yacht position tracking system using a web-based or smartphone. The user's application, namely the tablet, captain, will receive coordinates and then can send these coordinates to the vessel's tracking system to find out the position of the motor sailing yacht. Application that can be utilized into marine traffic. Google Earth is a feature of Google Inc. is accessible for free, which provides very detailed and efficient browsing of the world's satellite maps.
Your time 2 minutes left, Mr. Melan.
Conclusion and future research. This paper has presented global positioning system technology on motor sailing yacht in pelayaran rakyat maritime. Users can receive coordinates point and then send these coordinates to the vessel's tracking system to find out the position of the motor sailing yacht via captain. Trip routes can be seen in Google Earth in the marine traffic application, which feature a very detailed and efficient exploration of the world's satellite map. Therefore, as far as future research is concerned, other stakeholders can use the improvement of the design and implementation of information system motor sailing yacht with Android web-based approach. Thank you for the opportunity to present and thank you for your time.
Okay, thank you, Ms. Melanie, for interesting presentation. I invite all of you to have, if you have any question to Ms. Melanie. If there is no question, maybe I will ask you about have this technology has been applied with to how many people have already used this technology, Miss Melanie? Maybe you have some data, so people can reduce their
Yes,
cost.
actually, I don't have the data because this is a literature. So
Okay.
this model we made special for traditional motor sailing in Indonesia.
Okay, so probably it will be interesting if we can we can know how many people, how many fishermen have already used this technology. So I think they will have benefit for their operational costs, I think. Isn't
Yes,
it?
thank you for your input.
Okay. Okay, thank you, Ms. Melanie, for the presentation. Because of time limitation, we should move to the next presentation. If Mr. Isaac already ready, you can continue your postponed presentation. Isaac, are you ready?
Check, check. Can you hear me?
Check, yeah. You can continue your last presentation, Isaac.
All right. I'm sorry for the occur. I'll continue it from the last slide that I've shown. So for the background, flood as a natural disaster data based on a report from the National Disaster Management Agency have contributed as much as 27.3% in 2020 until the month of September. Disaster have increased by 129%, and this disaster is check. I'm sorry.
Okay. Yeah.
All right.
Okay.
I'm
You
so
can.
sorry. So from the background, we have an idea that we analyze extreme rainfall trend behavior over Jasa using man-Kendall test. So by knowing the extreme rainfall data trend, we could know the areas that might be having an increasing number of extreme rainfall value. And it's possible that those areas might have a higher number of extreme rainfall value in the future. Now for the study location, we use Java as our study location. This island is located in Indonesia and has a population of about 141 million people, which makes it the most populous island in Indonesia. And Java is also the island with the most floods in Indonesia. And this make this location strategic for our research. And now to the data reference. Data reference use only rainfall data, only rainfall data, and this data collected from the Climate Prediction Center, or called CPC, from Unified Precipitation Project. This data recorded from the satellite, and it starts from January 1st at the year of 1979 until 9 October in the year of 2020. So this data consists of 76 grids that cover in Java, and each grid have the size of 55.5 kilometer by 55.5 kilometer. This data in the format of netcdf. It could be opened by using RDS software, but in this research, they're processed in RStudio. And next, our step is easy. There are 4 steps for the method processing, and after that, we process it using Mann-Kendall test. After we know the trend, we use sand slope estimate. We have the result. So here is basically it find the in a time series. In this case, in a year there are 365 daily rainfall data. We choose one with the highest number. And here is the Mann-Kendall test. So we find the S value, D value, tau value, and the variance of S. And last test statistic, all of that. So the conclusion that we use in Mann-Kendall test is the null hypothesis is there is no trend. And for the alternate hypothesis, there is a downward or an upward trend. But in this case, in our research, we focusing on the upward trend. We use 10%, 0.1, then the null hypothesis will be rejected. So for the sand slope estimator, it's used to find the slope value of the trend data. And here is our Mann-Kendall test result. First, we show you the location of the grids that showing increased trend. There are 13 grids that spread across Java. The location can be seen in the picture. And next, here is the detail of our Mann-Kendall test result. As we can see, there are 13 grids, and it's the code to show the location. Basically, after that, we have the province location of the grid and also the city location of the grid. And the important thing to see here is the p-value. From the p-value, we can see all of them, all of the 13 grids have a value less than 0.1, which means the null hypothesis is rejected, which means there is an increased trend there. And from this data also we know the lowest p-value is DKI Jakarta, which is interesting. After that, we have the graph of the Mann-Kendall test result. So the x-axis is for time, and y-axis for the most interesting graph is at grid number 4 with the slope highest. And to know the slope value, we see the sand slope estimator result. In this result, it's also shown that the DKI Jakarta has the highest sand slope value, followed by Jawa Barat at the city of Bekasi. And from this result, we also know that Jakarta have the highest maximum daily rainfall between all of those increased trend grid, all of those 13 grid, which is really interesting. And in Province Jawa Barat, there are 4 cities that showing increased trend, Jawa Tengah only 2, and Jawa Timur also 4 increased trend. So let's discuss about the result, the most interesting one first from DKI Jakarta. So in DKI Jakarta, the trend is increasing, of course, and it has the highest trend slope and the highest daily rainfall data. And if we see from our flood data that we have from 19 and 1994 until 2018, it's also shown that there is an increased cases of flood event. And this is interesting because there is a possible linkage between flood data cases and the increasing rainfall trend. After that, we can see West Java flood cases. It's also increasing.
Your time 2 minutes.
Which is makes sense. West
Exactly.
Java trend
Your
also
time 2
increase.
minutes.
All right.
2 minutes. Yeah.
And then the last. All right, thank you. And for the last, to the conclusion. So for the conclusion, we know that there are 4 provinces consisting of 12 cities in the island of Java, which show an upward rainfall trend behavior. And the next is, the city of Jakarta is a district that has the highest upward trend slope value and also has the highest maximum daily rainfall. From here, we could know that it's possible in the future, Java will have a higher extreme rainfall value. And it's also possible the number of flood cases in Java will also increase.
Okay.
And the last is, it is possible that there is a connection between the upward rainfall trend behavior with the number of floods that have increased in a region. For the technical, I'll give it back to you.
Okay, Isaac, thank you for the presentation. I think the connection is not quite stable. I think so. It is quite difficult to hear your sound. I will invite any of you who has question, who can ask to Mr. Isaac.
Check. I'm sorry, I'm just reconnecting again.
Okay, if there is no question because of the connection problem, I think we cannot make discussion for Isaac presentation. So we can move to the next presentation is to Ms. Palupi again. We invite Ms. Palupi to present your paper, which title Did Socioeconomic Status Influence Psychological Preparedness for Potential Disaster of Residents around Lapindo Mud Disaster. Okay, for Ms. Palupi, the time is yours.
Thank you, Pak Purwanto. Let me share my slide. Okay. I hope everyone can see my presentation slide. All right. I will proceed. This is my second presentation. Good afternoon, ladies and gentlemen. My name is Listiatis Chopalopi. I'm a lecturer at Fakultas Psikologi Universitas Airlangga. And for this second presentation, I would like to share my research entitled Did Socioeconomic Status Influence Psychological Preparedness for Potential Disasters of Residents Around Lapindo Mat Disasters. This research is a part of a large project on psychological preparedness for disaster study that made possible by the fund granted by Indonesia Ministry of Research and Technology, National Agency for Research and Innovation, or Ristek-BRIN. I will present the finding of this research according to the following outline. First, I will describe the background of this study in introduction. The second part will be the method that was used in this study. The third is the result, and the last part is discussion. So, move to the introduction. Lumpur Sidoarjo, or usually abbreviated as LUSI, is a geological disaster that has been going on for almost 14 years, since 2006. The mud volcano is still erupting even up until now, and it's greatly impacted the life of communities around the site. People live around the site mostly relied on the ponds as a living. Those LUSI bring a devastated impact to the local communities. The condition has bring negative impact not only to their economic condition, but also to their mental health. Study found that there are a growing number of people live around the site that experience psychological problem. In only 9-month period from the beginning of eruption, LUSI has caused almost 14 billion rupiah losses. Besides of that, it is also found that the survivor of LUSI experience several psychological problems such as anxiety and depression. Research on the psychological impact of disasters has found that disasters could make the survivor develop acute stress disorder, post-traumatic stress disorder, and also other psychological disorders. Research found that the impact of disaster could be seen and provide prolonged impact to the mental health with survivor. Research found that on average, natural disaster has negative impact on mental health of the affected population. Study found that there are post-disaster mental health problems that has been identified, including post-traumatic stress disorder, major depressive disorder, and complicated grief disorder, substance abuse, and physical illness. Helping individuals to successfully manage a disaster situation or disaster impact and to cope with psychological problem could help the survivor to reduce the psychological impact that they experience. Morrissey and Resser found that individuals that are psychologically prepared could anticipate and identify their feeling and to manage their emotional responses that can enable them to cope with the stress from being exposed to a disaster. A study conducted by Najafi and friends that investigate the disaster preparedness of Iranian found that socioeconomic status is one of the factors that are contribute to disaster preparedness. People in high income status group were found to be more prepared compared to them from low income status during and even after the natural disasters. Research on preparedness for natural disaster among older US adults conducted by Rosens and friends also identified socioeconomic status as one of the factors that correlated with disaster preparedness. Although the role of socioeconomic aspect in disaster preparedness has been documented in several studies, however, the role of socioeconomic is still unclear in related to psychological preparedness for potential disaster, especially among residents around the mat disasters. In the present study, we evaluate the relationship between socioeconomic factors on psychological preparedness amongst residents around Lapindo mat disaster. Next, I would like to discuss the psychological preparedness for potential disaster concept that also I used in my first presentation. Yeah. So the psychological preparedness for potential disasters was drawn from disaster preparedness concept. According to Freeman, disaster preparedness is the state of readiness to deal with a disaster if and when it occurs. While the International Federation of Red Cross and Red Crescent Society define disaster preparedness as measures taken to prepare for and reduce the effect of disaster. That is to predict and, where possible, prevent disaster, mitigate the impact on vulnerable population, and respond to and effectively cope with their consequences. Move to the next concept, which is psychological preparedness for disasters. Yeah. Psychological preparedness, according to Morrissey and Resser, is a process and capacities such as knowledge, concerns, anticipation, recognition, arousal thinking, feeling, and action. While Zout define it as a heightened state of awareness, anticipation, and readiness for the uncertainty and emotional arousal in expectation of the possible occurrence of the threat, one's own psychological response to the unfolding threat situation, and the ability to manage the demand of the situation. While in this research, we applied ABC attitude model to define psychological preparedness for potential disaster as a person's attitude toward disasters that could be predicted in terms of affection, which is how a person's emotional reaction toward disasters, and then cognition, which is knowledge and belief that a person have toward disasters, and behavior, which is a person anticipation behavior to reduce the risk of disasters. From the previous studies, we found that there are several factors that influence disaster preparedness, which are gender, age, socioeconomic, and education. Move to the next slide, which is meta. In this research, the method that we use is survey research, and the participant involved in this study was 30 participants that live in Kupang village, Sidoarjo. This is the region near the Lumpur, Sidoarjo. And the participants should fill the psychological preparedness for potential disaster scale that consists of 3 parts, which are informed consent, identity, and the scale itself. The participants should put their agreement to be involved in this research in the informed consent part before they could move to the next part. Participants who agree to participate in this research fill their identity, and then next fill the last part, which is the scale. And this scale is consists of 71 item version, which include 35 items of affective dimension, 30 items of behavior dimension, and 23 items of cognitive dimension. And the internal consistency of this scale is 0.796, which is considered reliable and valid. The analysis that we conduct for the study is using Fisher-Irwin test to determine association between socioeconomic indicator measured by income and the psychological preparedness for potential disasters among residents around Mat disasters, Sidoarjo. And all the analysis were carried out by SPSS versions 26. Next, I will be presenting the finding of this study. First, I would like to describe the demographic profile of the participants based on the socioeconomic status.
Ms. Palupi, you have 2 minutes.
Okay, thank you. Next will be the participant profile of psychological preparedness for disaster and the relationship between socioeconomic status and psychological preparedness for disasters. Okay, because the time limitation, so I just move to the hypothetical testing. From this result, from the Fisher exact test result, we could see that the Fisher exact test is a 3.561, which is above the p-value, which is 0.151, and therefore the analysis showed that there is no statistically significant association between socioeconomic status and this psychological preparedness for potential disasters. This finding is in line actually with a previous study that conducted by Gladwin and Peacock in their study on the household preparation of the South Florida community. In the study, they found that the disaster preparedness and a socioeconomic status is not significantly correlated. In this case, it was found that the time between beginning preparation and the onset of the Hurricane Andrew did not vary significantly by income. It is concluded that people did not prepare themselves in advance prior to disaster. This is also become the case among residents around Lapindo Mat disaster. Vast majority of the participants were less psychologically prepared for potential disaster. We can see that from the result. In the pie chart that I skipped, and this happened due to the economical condition that were mostly in low and middle income category that made them unable to invest more in preparing themselves for disasters. This is also highlighted by the report made by World Bank and the Global Facility for Disaster Reduction and Recovery. In their report, they note that poor people with fewer resources or invest less in preventing and mitigating the adverse effect of disaster caused by man-made or natural disaster. In conclusion, we could found that psychological preparedness for potential disaster among the residents around Pindomat disaster was not affected by socioeconomic status due to their economic condition. Thank you for listening.
Okay, thank you, Ms. Palupi, for your interesting presentation. I invite all the audience, if you have any question to Ms. Palupi, you can ask directly to her. Okay. Ms. Palupi, you say that socioeconomic is not affect the psychological preparedness for potential disaster. So what is your suggestion? So people have more psychological preparedness according to your result?
As I've already explained, that this research is due to the economical condition. Most of the participants in the study were lies in middle and low income categories. So economic status were in the middle and low. Therefore, they haven't had enough resources, to invest more in the psychological preparedness for disasters. Of course, this should be solved by government policies, to provide the basic things, that are required to prepare themselves for disasters. For example, such as perhaps what we call it, a smoke detector. If we see in the developing countries such as Australia, each houses or each unit of apartment have their own smoke detector alarm that are connected with the firefighter station. So this kind of policy could help the residents around Mat disasters, Sidoarjo, to enhance their preparedness. And eventually, when their physical preparedness is increase, of course, the psychological preparedness will also increase as the increase of the physical preparedness. Thank you, Pak Purwanto.
Okay, thank you, Ms. Palupi. I think it is the last presentation for this session because the other two presenters not join this room. So I would say thanks to all the presenter, Mr. Ahmad, Prof. Ahmad, and also all the participants who has joined from the beginning until the end of the session. Thank you very much. I apologize if I have any comment who not inconvenient to you all. So I apologize. So I will hand over back the time to the organizer for the next session. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Terima kasih
wabarakatuh.
Terima kasih.
Pak Dr. Purwanto.
Sama-sama.
Ya.
Yeah.
Thank you for Mr. Purwanto as the first moderator. First of all, I would like to introduce myself. My name is Diandra and I'm the MC for today's event and I'm helping the moderator. Ladies and gentlemen, welcome to session 2 for today's event. We will continue to hear the presentation by our participant. Also, I would like to introduce the moderator for this session. Please welcome Ms. Doctor of Engineering Shadi Rahmawati, STMT. For Mrs. Doctor of Engineering Shadi Rahmawati, STMT, the time is yours for taking the session 2.
Thank you very much, Ms. Diandra. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Can you hear my voice clearly? I suppose it's Ms. Diandra. Can you hear my voice?
Yes,
okay,
I can.
Good afternoon, ladies and gentlemen. Welcome back to room 3 of ISOCEEN 2020. My name is Shadi Rahmawati, and it's my pleasure to be the moderator for this session. I will be quick because we already passed the schedule. Ladies and gentlemen, in this session, this afternoon, we will have 10 presenters. Each of them will present their paper for 10 minutes, and then we will have discussion for 2 minutes. Ms. Diandra, please, you can help me for the timekeeper. Okay.
Okay.
Yes, thank you. First, we would like to have a presentation from, sorry, I will check again. The first paper entitled Analysis of Work Accident Factors in the Shipyard, presented by Mr. Badruzaman, Mr. Alam Baharam Shah, and Mr. Ayasari. Please raise your hand. Who will represent this paper? I will check. Please raise your hand for the presenter. Okay. I will ask for the next paper while we are waiting for the first paper. So we continue to the next paper entitled Evacuation Analysis of Ship Passenger Using Agent-Based Modeling Simulation, also presented by Mr. Badruzaman, Mr. Siswantoro, and Mr. Zulfikar. Are you there? Can you hear my voice? Please raise your hand. I mean, raise hand, not raise your, literally, your hand. Is there any representation? Mr. Nur Hadi? Are you going to share your screen, or from the committee will help you? Ms. Nuradi Siswantoro, we cannot hear your voice. And also, please turn on your video. Okay. You have 10 minutes to present. We cannot hear your voice. I'm sorry. Okay. I'm sorry. Your voice is not come out yet. Probably not using the headset. You can use your PC. I'm sorry, no voice yet. Speakernya bisa kan ya? Coba kamu agak kencengin. Okay. Mr. Nuradi, we cannot hear your voice. Probably you should change your microphone in the bottom left near the microphone icon. You should choose your microphone as built-in or external. Which one do you use? And the left bottom of the Zoom screen, you can see the microphone. You can set the microphone setting. I'm sorry, we still cannot hear your voice. Can you try again? Still no voice. Maybe you should check the bottom left on the microphone icon. There's like a arrow. Then you click there and select microphone.
Hello.
Oh, okay. I can hear your voice, but it's very small.
Hello, Pusati.
Oh, okay. Yes, we can hear your voice. Okay, good. Okay.
Thank you, Pusati.
Okay, please start your presentation.
You can see my slideshow, Pusati.
Yes, we can see your slide.
Okay. Thank you very much. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the moderator, Bu Sati, and then for the other participants in ISOCEEN 2020. Okay, today I would like to present our research about the evacuation analysis of ship passenger using agent-based modeling simulation. We are from Marine Engineering Department in Digital Marine Operation and Maintenance Laboratory. I am Nurhadi Siswantoro, and the other researcher is Muhammad Badruzaman and Manas Zulfikar. In the introduction, as we know that in Indonesia has an increasing of the number of the passengers in the every years. Impact of the increasing of the number of passengers in the ships. Yeah, there have a ship accident in Indonesia, such like the sinking, fire, collision, grounding, and others. Totally from the 2012, 2013, 2015, 2016, and 17, we we have the increasing of the accident in Indonesia. The total from the 2012, 4, 2013, 6, 7, 11, and 18, and the last 2017 34. The database from the National Transportation Center, or we call it KNKT. The effect of the ship accident in Indonesia, we divide by the 2 fatalities on the injuries and also loss or died people. The start from the 2012, the total of the fatalities is 23, 2013, 74, and 2014 decreased to 26, but also into 2015 increasing again at 87, and 2016 63, and the last data from the 2017 is 44. It's also the results from the database of the National Transportation Safety Committee. Here are the, according to the backgrounds and the introduction, we have the problems analysis. Yeah, the first, how to model the passenger evacuation using an agent-based model simulation in ideal condition and the overload condition. And the second, what is the total evacuation time in the day case based on the IMO data according to the MSC 1533 guidelines, and the third is what is the total evacuation time for the night case based on the IMO data. The goal is knowing the passenger evacuation modeling using an agent-based model simulation in ideal condition and overload condition. The second is knowing the total time evacuation in a day case, and the third is knowing the total time of the evacuation in night case based on the IMO data. The limitation here, we are using the simulation is type of the passenger ship, and the scenario used in the ship is a normal condition and also evacuation condition. And the evacuation scenario use the advanced analysis according to the MSC 1533 guidelines. Okay, the methodology here is the start, yeah, and then the formulating the problem, study of the literature from mainly from the paper, journal, and others, and then the collecting data from the company about the general arrangement and also the safety plan of the ships, and then next we are calculate the simulation according to the evacuation analyzing using agent-based model simulation based on IMO guidelines for the day case, and the next for the night case. So after we have the result of the day case and also the night case, we can make the conclusion and recommendation. And then the finish. Okay, start from the collecting data. The first data, we are using the data from the IMO guidelines. Here, the data about the population groups in the passenger. As we can see at the table in the left side, females younger than 30 years, the percentage of the passenger on the ships, 7 people, female, the 30 until 50 years old, 7%, female older than 50 years, 16%, and then until the males older than 50 and mobility impaired 10%. And also we in the guidelines also give the percentage of the crew. Yeah, here we divide by crew females and males. And then the next table, the population passengers compare with the walking speed on the flat terrain. Yeah, you see at the working speed, we are using the uniform distribution. So the working speed divide in the minimum and the maximum. This is showing the working speed, female and males, and also the crew, female or males walking speed on the flat terrain. Okay, and besides the IMO data, we are also checking the data from the company about the general arrangement and safety plan for the passenger ship. Here we have some data about the principal dimension, about the ships, the length overall, the length of waterline, and then width, height, draft, GT, speed, the numbers of the passenger, and also numbers of the crews. Then after we are collecting the data, we are using the Pathfinder, the agent-based model simulation. We are modeling using the Pathfinder software. Here this Pathfinder software 2019. The first step, we create the ship modeling, includes the rooms, doors, corridor, and also the stair. Here you can see the corridor and also the rooms and the others data. And then also how to make the door. Here is the door, and here this corridor. And then this one we make the modeling. The modeling is the 3D modelings for using evacuation. This is from each deck. This is the decks in the ships. Yeah, in the completely decks, there are rooms, then corridor, and also stair. The stair also needs to connect the first deck to the second deck and the next deck. And after we are modeling the rooms and the others, the next step is setting the occupants of passenger. This passenger, we are using input to the modeling in the software according to the value of IMO cat lines, the distribution of the occupants, and also the speed, minimum and the maximum speeds. Here you can see at the picture in the in the right side, this one is the people, the people, and then the every deck of the ships. And then also we are setting the behavior in the agent-based model simulation. The agent is the model of the occupants, representation the occupant. We are setting the behavior is good to any extent. So the occupants can move from the one point to the next point, and then going to the master station and go to left the ships for the evacuate himself. This is the distribution. This is the distribution of the occupation. We are setting from the IMO data. And then the last is the simulation. In the simulation, we are concludes the day case and also night case. Why? Because the advanced analysis in IMO cat lines in 1533 cat lines, the cat lines give the recommendation for making simulation in the day case and night case. In the normal evacuation, yes.
Your time is up. Can you pick your
okay? Thank you, Pusate. This is the result of the evacuation In the night simulation, in under normal condition, we have the simulation is 38.24 minutes, and for the night simulation under evacuation condition, 36.45 minutes. And for the overall, this is the conclusion. From the passenger evacuation simulation, we have the evacuation day time for the case normal condition have 29.49 minutes, and then the daytime evacuation 28.12 minutes, and normal condition for night case is 38.24 minutes, and the evacuation condition is 36.45 minutes. And then the passenger ship simulations, the capacity of today, the capacity is 880, can be up in the 1,527. And then from all the simulations, this under the guidelines IMO, yeah, because the limitation of the simulation for the evacuation is 60 minutes. So this rules was, the general arrangement, it's good. I think it's proven because the evacuation simulation is under 60 minutes. Thank you for the presentation. Thank you, Pusati, and the opportunities.
Thank you very much. Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Nur Hadi Siswantoro, for your presentation. Is there any question from the audience? Please raise your hand or write it down in the chat room. Okay, Mr. Siswantoro, I have questions. So on your research, the evacuation analysis is only limited to the ship passenger. How about another kind of ship, like maybe for the cargo ship
or something?
Can you apply the same method to the other type of ship?
Okay, thank you, Pusati. For the simulation, according to the IMO guidelines, is this special for the passenger ships, but also that if the rules comply to the other ships, problem, but we have to considering about the time limit for the evacuation. Because in the guidelines is special for passenger ship, but using the agent-based model simulation, we can also make the simulation for another ships. But maybe about the regulation, we'll check again.
Okay, thank you very much. Yes, thank you very much, Mr. Siswantoro. So I think it's very interesting presentation. Okay, thank you. So we will continue to the next paper. Thank you very much. Okay, I have been informed that Mr. Badruzaman have arrived here. So can you present your paper, Mr. Badruzaman? Are you? Can you hear my voice? Please. Oh, okay. Mr. Badruzaman, seems like there's a technical problem, so I will continue to the next paper entitled Hybrid Photovoltaic Thermal Solar System for Brackish Water Reverse Osmosis. The author is Mr. Sutopo, Mr. Alam Bahiramsyah, Mr. Agus Santoso, and Mr. Yudi Satrio Santoso. This paper will be presented by probably Mr. Sutopo. Okay, Mr. Sutopo, can you hear my voice? Jadi unmute. Please unmute unmute your.
Yes, Bu Sade.
Okay. Thank you very much.
Yes. Can you hear my voice?
Yes, it's very clear.
Okay. Okay, let me share my slide first. Can you see my slides, Bu Sade?
Yes, you can see your slide.
Okay. Okay, let's me start. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. So, my name is Sutopo Purwono Fitri from Marine Engineering Department. So today I'd like to present my paper with the title of Hybrid Photovoltaic Thermal Solar System for Brackish Water Reverse Osmosis. So maybe before I start my presentation, I'd like to say hello to my colleagues from Malaysia, Professor Ahmad Fitriadi. Assalamualaikum, Prof. Ahmad Fitriadi. Maybe if you hear me. Okay then. So yeah, the team has a project. Did it by the kind of project of a student. So it's make an experimental study to develop a hybrid photovoltaic thermal solar system. So this is my today's outline for presentation. And okay, let me start with the introduction for a condition a limited clean water access. So as we know, in Indonesia and also around the world nowadays, facing the water crisis problem. Yeah. So in Indonesia, we have a data that the service of clean water from government only 80%. Yeah. So about 20% population in Indonesia haven't got any clean water services. Yeah. So they cannot drink water easily. They cannot get the water for take a shower or just for washing the plates. Yeah. And as we know also that the majority of Indonesian population lives in coastal areas, yeah? Like in big cities Indonesia mostly, yeah, in the coastal area like Surabaya, Jakarta, Semarang, and so on. Yeah? And of course, the inhabitants mostly they populate in the big cities. Yeah? So they sometimes using a groundwater. The groundwater in the big cities usually saline water. Yeah, it's not the pure fresh water, but the brackish water. So this is a big problem for people. Yeah? And also the local water company like PDAM, yeah, PDAM also has a small capacity. This is also a big problem when we enter the dryness season. Many areas has very limited access of clean water, yeah? And then the PDAM cannot also supply the fresh water or clean water. And also the condition of river and lakes in Indonesia contaminated with industrial pollution, yeah, chemical pollution, oils, and also the debris, yeah, debris trash from the people. Yeah. And right now in Indonesia, still a few projects of distillation or desalination, yeah, because of relative expensive compared with the wells, yeah, the groundwater wells, and also limit capacity and also require high. Yeah, that is to focus because the groundwater, yeah, many groundwater is saline water and also a few projects of desalination. So we have also many facts that we have abundant solar energy, yeah? about 4.8 until 7 kilowatt hours per square meter per day. And also the conventional reverse osmosis requires high power pumps. Yeah? So this is also require attention when we design an RO system. Yeah? And there are two technologies that dominant applied for water processing. Yeah? The reverse osmosis and the distillation. Yeah? The reverse osmosis occupied 47.2%. Yeah? That usually for brackish water, reverse osmosis need 1 until 3 kilowatt hours per cubic meter. This is specific. This is the specific energy consumption. Yeah? And the brackish water usually have TDS from 500 until 30,000 ppm or milligram per liter. And of course, the old technologies has been developed, yeah, to get a more lower consumption and also cost. Yeah. So the proof of our research is to make an experimental study using 75 gallon per day system, brackish water reverse osmosis, and applied hybrid PV and solar collector system. And the second one is to investigate the effect of increasing feedwater temperature versus the TDS product, the compressor power and salt rejection, and also to know the requirement of PV power. So this is the method for our research, and this is the configuration that we have done our research. So this is the hybrid PV solar collector BWR or brackish water solar brackish water reverse osmosis. So the solar collector here, this is the PV array, yeah, and we have also the RO membrane here. And for our study, we also applied a post-treatment here using a ceramic, yeah, ceramic filter. So this is the main component of our reverse osmosis system. Yeah? The solar collector, we use a 70-row solar collector to collect the irradiation intensity, the solar energy, to increase the temperature of the feed water. Yeah? And also the PV cell, yeah, to supply the electrical power to the pumps. And we have two-stage recirculate concentration system of the RO system. Yeah? So the recirculate concentration system is to using two states. So the brine water from the first RO membrane will be entrance the second membrane. Yeah. So and then we have a permeate flow of the product water, and then the final brine water will be sucked by the RO again. So this is required to increase the amount of product water. Okay? This is very efficient and also benefit for small systems. So this is our specification for PV solar collector BWRO. This is a system for 75 GPD, and we use 2,200 ppm of the brackish water. This is a process of slightly saline water. Yeah, this is a typical brackish water found in the area around Kenjeran area, yeah, in the Surabaya. So we use also to solution concentrate system. We use a type of spiral wound membrane for reverse osmosis, and solar collector used as a preheater, not as a steam generator for any kind of system, but only just as a preheater for this kind of hybrid solar collector PV system. So we have a size around 1.5 meters, yeah, times 1 meter, and the thickness 150 millimeters, yeah. And we have a tube row in supporting connection, yeah. And also we vary the temperature, yeah, that entering the air membrane. We vary for 31 degrees of Celsius, 35, and 40 degrees of Celsius. And at the end of the premier product water, we use a ceramic membrane for post-treatment to have more high quality for drinking water level. So in our research, we focus on the design and also the experimental study that we have made on the system. Yeah? So the first one, the analysis for solar collector, this is related with the energy in the solar collector that can be absorbed by the solar collector based on the solar irradiation and how much the heat occur. Yeah? And also the feed water temperature, and also we made the collector is 30 degree tilt to receive the solar irradiation about 900 watt per square meter. So this is the data that we have taken for temperature distribution on the fluid and also on the solar collector itself. So the first performance of the reverse osmosis system using solar collector is the effect of the feed water temperature variation versus the TDS of product water. Yeah. So in this case, all the experiment we have made 2 iteration running. Yeah. So this is the experiment 1. This is the experiment 2. So in this case, we can see that the increasing in the temperature of the feed water, yeah. So this is the blue one, yeah.
Mr. Stopo, your time is up, so can you please
I'll try to speed up, yeah. So overall, the effect of temperature will the increasing of the temperature will increasing the TDS, yeah. And also this is the effect of temperature versus the pump pressure. You can see that the increasing in temperature of the feed water will decrease the pump pressure, and also, of course, will decrease also the pump required by the pump, yeah, that was supplied by the PV system. And the salt rejection is the reverse. Yeah, inversely result that the increasing of the feed water temperature will decrease the salt rejection. Of course, this is the disadvantage of the system. And the rest in simulation for PV. So we got this model, and also we need the 930 watt peak and efficiency of about 12%, and this is the peak required power at 40%, 40 degrees Celsius. So this is the conclusion of our presentation today. Okay, thank you. Any questions?
Thank you very much, Mr. Stopo. So it's very interesting application of solar panel, right? Okay, so if anyone has any question, please raise hand or write the question. I will read the question. Okay, Mr. Stopo, I have one question. Yeah. So in this system that you design, wait a minute. I'm sorry. What is the meaning of a hybrid here? So I mean, which system is more dominant between the photovoltaic or the thermal solar system? Which one is have the most role on the system to generate the electricity?
Yeah. So in this system, the hybrid of PV and solar collector system means we using the solar collector just to preheat the feed water temperature, and the PV only supply the electrical power. So many kind of hybrid system like solar thermal system, they use the steam generator inside the solar thermal system to generate steam and then provide a power in the fleet and then rotate the turbine. Yeah, this is a kind of Rankine system. Yeah, and then the turbine will rotate a generator and produce an electric power. So this is another type of hybrid combination between PV and a solar system. In our research, the solar collector is not produce an electric power, but only increase the temperature in order to make a contribution to reduce the requirement of electrical power of the pumps. Yeah. And the electrical will supplied by the PV only.
Okay, thank you. It's very clear explanation. Okay, if there are no other questions, thank you very much, Mr. Stopa, for your presentation. It's very interesting topic.
Okay, thank you.
So we will continue.
So, I will stop, yeah?
Okay, thank you very much.
How to stop?
It's already, I think the screen share already stopped.
Okay.
Yeah. I will
thank
continue.
you. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Stopo. And we will continue to the next paper entitled Analysis of Extreme Events Through HF Radars Wave Height Observation in the Southwestern Iberian Peninsula, presented by, pardon my spelling, probably is not correct, Miss Isabel Bue, Mr. Alvaro Semedo, and Mr. Joao Catalao. I'm sorry if I pronounce it wrong. Okay, Miss.
Hello?
Okay, yeah, hello.
Can you hear me?
Yes, clear.
Okay. Good afternoon to all.
Afternoon.
Good afternoon.
Okay. Can you see my slides?
Not yet.
Sorry. Okay.
Okay.
Okay. Good afternoon to all. I'm presenting the results for my PhD works. And the title for today is Analysis of Extreme Events Through High-Frequency Radars Wave Height Observation in the Southwestern Iberian Peninsula. The Iberian Peninsula is located in Europe and is strongly influenced by low pressure systems directly from the mid-Atlantic Ocean that give rise to storms and severe sea states. The south coast of the peninsula is a region with intense maritime traffic between the Atlantic and the Mediterranean. For this reason, characterization of the wave height events is mandatory to increase maritime safety in coastal areas, to minimize the associated risks, to provide continuous monitoring of coastal areas, and to achieve reliable wave climate statistics. The study that I will present today will evaluate the skills of the high-frequency radars in the southwestern Iberian Peninsula through analysis of wave parameters measurement during extreme wave events. This is the study area, and we will analyze significant wave height measurements from 4 CODAR CSUNS radars which are located here. And the wave heights will be compared with 3 wave buoys, which are located here as well. We analyzed these data sets during 36 months, from January 2017 to December 2019, and for different storms periods. These are the 4 different radars that we have analyzed. And these radars are capable to retrieve currents from 100 kilometers from the coastline, and as well wave parameters such as significant wave heights, wave periods, and directions. These parameters are obtained by applying an oceanic wave spectrum model, such as Peirce-Moskowitz, to the second order spectrum obtained by the radar. The second order spectrum, which has lower energy than the first one, which is utilized for the currents, is closer to the noise floor and consequently easily to be contaminated. So it is more difficult to extract wave parameters from the radars. And this information we can only obtain until 30 kilometers from the coastline. The information we can extract from rain shells, which are these circular areas, and have a different width from specific distance, counting from the radar antenna, corresponding to the rain shell spatial resolution. So for the wave parameters, we only can retrieve information until 25 to 30 kilometers from the coastline. So we compare this information to the in situ data, which we had extract from the buoys. And we have chosen the furthermost rain shell, the information which is contained in these the furthermost rain shells, to be compared with the buoys. These are the distance that we have to achieve to compare the data. But we have some problems because the second order spectra is more weaker, so we have less data. One thing that homogeneity ocean spectrum through each range cell is a characteristic from this type of radars, and the information is better neither too far or too close from the antenna origin. So we will have different availability among the different range shells. We have analyzed the data, and after we have extracted the radar nulls and other spurious values, we only achieve this data to be compared. The best range shells and the radars that we have to compare was the Alpha and Sagres stations, and Maza and Vila Real have low data to be compared. Individual graphs we are presented here show the same thing, that the Vila Real is have low data to be compared, as well as Maza, which have less than 40% of data. We have analyzed 5 different events or storms. The first one occurred in December 2017. The second was Emma, which occurred in March 2018. Then we had Felix, also in March 2018, and 2 more storms in December 2019, which are the values of the maximum significant wave heights. Sorry. We analyzed the time series of the data, and we produced the QQ plots from these extreme events. To analyze if is an extreme event, the percentile of 19 and 99 of these data were plotted, and these are the extreme events. For this buoy, this Faro-Oceanic, to be considered as extreme events, the significant wave heights has to be more than 4 meters. And these values were achieved in all the graphics.
Excuse me, Miss Isabel.
Yes.
Your time is less than 5 minutes, so can you please wrap up?
Okay.
Thank you.
As well, for the other buoys, we have do the same work, and the results are the same. And after that, we have compared the significant wave heights for all the data sets. And the result is that we have overestimation, as you can see by the radar in all, the most part of the graphics. And we also plot here the statistics. This is for alpha station. I have a very good correlation data in here with 0.89. And the same results for the other stations. For a Masa station, we only can plot this graphic because we have data available only here. So to present the results in the discussion, a significant wave height overestimation is clearly noted in the graphics by the writers. In the presence of low sea states, the strength of the second order spectrum can be very weak, and superior contributions to the spectrum have a significant impact. The study area is a natural sheltered and characterized by low sea states below 2 meters. Coder CSUN systems assumes homogeneity of the ocean spectrum that can be a problem and induced to over or underestimation by the radars. Comparatively with buoys, proximity to the radar sites and its lower maintenance costs ensures continuous data return. The low availability of wave data in 2 of the sites has also contributed to its lower performance. The distance from each range shell to the radar or the difference in the sea states along the range cells may lead to different wave data availability, and the mitigation of the discrepancies between mentioned as before can be carried out with new updates from the system software. As a conclusion, great potential of the radar stations are presented here. In situ observation can benefit from higher resolution and improved temporal sampling provided by the radars. Combining the observational strategy between in situ and remote sensing sensors during extreme wave heights and provides wide monitoring analysis in coastal areas. And in situ wave monitored gaps along coastal areas can eventually be overcome by these kinds of sensors. And we will expand our study to other comparisons between radar altimetry as a Sentinel-3. So if you have any question, thank you for your time.
Thank you, Ms. Isabel. Very interesting topic of your sharing. Okay, for all the audience, if anyone has questions, please raise hand or write down the question on the chat. While we wait, I have question for Miss Isabel. So in your results, there's this, I think it's big discrepancy, like the offered estimate results. So what is the most, what is most the possible cause of the offered estimate results, and how can we, overcome?
Because the study area is a very sheltered area, we have a lot of measurements below the 2 meters of significant wave height, and the radar cannot resolve the problem because the radar echoes is too close to the radar floor, that several spurious contributions are input to the data sets. So it's because of this sheltered area. We have extended our experiments to other areas with other radars, and we have better results because the operation frequency from the radar is higher, and we don't have this kind of problem.
Okay, thank you. So so the problem is not the resolution of the radar. So each radar have their own different resolution or the same?
They have different resolution. It depends from the sites and the width of the resolution cells. So we can get data until 10-15 kilometers, and in other radars we can get wave data until the 30 kilometers from the coastline.
Okay.
This for the wave parameters, because for the currents we have the current information until 100 kilometers from coastline.
Oh, okay. Yes. So I mean, the research, should be separated between each radar because it has different resolution. So I mean, the accuracy of the results is probably different, right? So you can you compare the I mean, it's not like apple to apple, like, because it's from different radar, no?
No, because the system is the same. So the only difference is the resolution of the range cell. We have radars which allows us to capture data from different areas. So we have the alpha radar is the best one because the data, as you've seen, are better. But the radars that are in the sheltered areas, as we have low significant wave height, they cannot acquire this kind of data.
Okay. Okay, very well. We have one more question, if you may. So, how long is the data sample measurement? Is it 20 minutes, or it can be faster or a shorter time?
We have 10 minutes from this kind of data. We have resampled the data in hourly, and after that we compare with the buoys. But the acquisition of the data from the radar is for 10 minutes. And we also have the 10 and 10 minutes we have an observation, because is the mean of the 10 minutes of observation. We have one data. So for each hour we have five data sets to be compared.
Okay, Thank you very much. I think it's very clear explanation. Thank you, Ms. Isabel. I think the time is up, so thank you for your presentation.
Yeah.
Okay, so we will continue to the next paper. The next paper entitled Estimation of Total Suspended Solid Using Satellite Sentinel-2 on the Pamekasan District. The author is Mr. Asari Wicaksono and Mr. Adis Siswanto. Are you there? So if you already here, can you raise hand? Okay, not yet. So we will continue to the next paper. I'm sorry, I will check the information below. Okay, so because the next paper entitled Parameters Influence the Stability Test of the Cluster Structures Model in the Laboratory, the author is not arrived yet. So is that true, Miss Diandra? I should check again.
I think number 14 and 15 haven't in the room yet. We can
Okay.
move on for number 16.
Okay, thank you very much. So we will
You're
continue
welcome.
to the next paper entitled Bias Correction of Ensemble of Wave Climate Projections towards the end of the 21st century. The author is Guillermo Alvaro Semedo, Mikhail Dobrinin, Melissa Menendez Pedro M.A. Miranda. Please raise hand for the author so we can unmute you.
Hello, can you hear me?
Yes, you can hear your voice.
Hi, good afternoon. I'm sorry for not being using the virtual background, but my face was being covered by it, so I wasn't able to use it properly.
Okay.
So, okay, let's start. I'm going to share my screen. Okay. Are you able to see it?
Yes, it's clear.
Okay. Okay. So, okay, let's start. Good afternoon, you all. It's 6:15 in the morning here in Portugal. My name is Gil Ems. I'm from the University of Lisbon. Today, I will talk about wave climate projections and bias correction and what are the effects of bias correction in the future results. My work is entitled Bias Correction of a Single Forcing Dynamic Ensemble of Wave Climate Projections Towards the End of the 21st Century. And so first things first, we are dealing with the wind waves, which are caused by the transfer of momentum from the wind to the water. These are actually the most energetic ones at the sea surface. And we should really care about the waves in the future due to its strong impact in coastal hazards, in offshore infrastructures, because they define ship and coastal and offshore structures as well, and impact the operability and safety factors of the offshore structures. Present climate wave conditions can be obtained with reliability from in situ observations, altimetry measurements, voluntary observing ships. However, to obtain future wave climate conditions, we have to rely on modeling efforts using global circulation models and wave models, which are always biased. So this is actually a problem. So our aim is to find out what happens to the projections when we include bias correction based on the current performance of the wave models. So our wave climate projections are built by forcing the WAM wave model with 7 climate runs from the EC Earth GCM. We obtain parameters such as the significant wave height, the mean wave period, mean wave direction, and wave energy flux. We have a 7-member ensemble. We divided the simulation into 2 time slices present climate and future climate, present climate from 1986 to 2005, and future climate from 2081 to 2100. And what we do is we correct the biases using a method that I will define a little bit later in the present climate using the new ERA5 reanalysis. And then we apply the same bias correction parameters to the late 21st century time slice, to our future climate time slice. Here we aim to assess not only what are the bias corrected projected changes, but also what is the difference between the original and the corrected projected changes, and what is in fact the impact of bias correction in our projections. So here on the top left corner is a definition of the empirical Gumbel quantile mapping method, which is the method we are using. Short, it's EGQM. It generally consists of just removing the difference between the simulated and the reference distributions at each one of the quantiles. And these quantiles are chosen using a Gumbel distribution, which focuses on the upper quantiles, so gives more emphasis to the extreme values. On the top rows, we have for our ensemble the biases, the original ones, the original biases for the mean and for the extreme mean, which is the mean above the 99th quantile, significant wave height at your left and mean wave period at your right. We can see that the original simulations tend to overestimate significant wave height and mean wave period, significant wave height more at the extratropical latitudes and mean wave periods more at the tropical and subtropical latitudes. On the bottom rows, we have the same averages, but upon corrections. So we can see that the biases are extensively reduced, and we can see that the results after the application of bias correction are much, much better. Not only are the biases extensively reduced after bias correction using this method, but the matching between the distributions of the simulated and reference variables also showed a great improvement. In the top rows, we can see that all the positive values correspond to an improvement. So basically all the values are positive for the entire distribution and for only the values above the 99th quantile, which mean that the match between the distributions increased. So this is a good result. In the bottom row, we can see the differences between the skewnesses of the two distributions before and after correction, and the green areas basically correspond to areas in which the skewness between the distributions difference reduced to close to zero as well. These are the results for the significant wave height. For the mean wave period, we can see that the distributions also increase in the matching after bias correction. So these are good results for the present climate, which mean that the bias correction method is able to reduce bias in the present climate simulations. So we saw that the empirical Gumbel quantile mapping method was able to correct the biases in the present climate simulations, and then we applied these same bias correction parameters to the future climate projections. Here we see on the left the original projections without bias correction, on the middle the corrected projections, so with bias correction, and on the right we see the differences between the original and the corrected bias projection. The areas without hatching are areas in which the magnitudes of the projected changes increased after bias correction. So these are actually the areas which interesting us. These are for the annual cases, December, January, February, and June, July, and August. So the extreme seasons. I'm just doing focus on the extreme means because we do not have much time, and these are actually the most interesting results and the most threatening events. We can see that first, upon correction, the area with positive projected changes in the significant wave height increased for the annual and seasonal cases in 3, 5, and 5%. So the area with positive changes in significant wave height increase, but also we can see that during the extreme seasons, we can see the most interesting differences between the original and the corrected projected changes, mostly in areas which are dominated by tropical cyclones. And this could be caused by the misrepresentation of tropical cyclones in the global circulation models, which is passed to the wave models and shown in our simulations due to the coarse horizontal and temporal resolution of these simulations, which is not able to deal with the tropical cyclones well. We can see enhanced decreases in the tropical latitudes of North Atlantic between 6 and 9% in June, July, and August. And we can see enhanced projected increases in the tropical latitudes of the Western Pacific, up to 15%, so 15% difference between the original and the corrected projected changes, also in June, July, and August. Now, for the extreme mean wave period, we can see that the greatest differences on your right between the original and the corrected projected changes occur at the low to mid latitudes of the summer hemisphere. So once again, seasonally, we can see the biggest differences. And these differences are mostly positive, so they are enhanced projected increases, so the increases are enhanced upon correction. And we can see that these differences are not only related to the misrepresentation of tropical cyclones, but are also possibly related to the parameterizations used for swell attenuation in the wave model, which are, of course, they try to represent what happens in reality, but these are only parameterizations, so they have an error associated to it, and so these biases were corrected, and here we can see the differences that this bias correction made to the values of the extreme mean wave period on the corrected simulations. Using the mean wave period and the significant wave height, we computed also the wave energy flux, which is proportional to the mean wave period times the significant wave height squared. This gives us a measure of the energy which is linearly carried by each meter wide section of water. So this is a very important parameter. And for the wave energy flux, we can see that the results are much more striking overall. So the differences between the original and the corrected areas of projected changes, positive projected changes, increased a lot. So we can see 5% increase on areas with positive projected changes at the annual scale, and 11% on the areas of positive projected changes in December, January, February, close to 7% in June, July, and August. But we can see also that the differences in the magnitudes of the original and the corrected projected changes, so the non-hatched areas in the right panels, are also greater. Despite being similar to the differences for the significant wave height and for the mean wave period, especially in June, July, and August, we can see that the enhancement of the projected decreases in the tropical North Atlantic reaches almost 15% compared to the original projected changes, and the enhanced increases in the Western Pacific reaches almost 25% after bias correction. So this means that bias correction increased the already projected increases in more 25%. So in absolute numbers here in the Philippine Sea, Western Pacific, we are talking about an extra 50 kilowatts per meter of wave energy flux due to the bias correction. So this is quite a difference, and this is one of the relevances of this method. So just to finalize, we just studied the relevance of a quantile-based bias correction methodology in the estimation of the projected changes was acknowledged because it is able to deal with the misrepresentation of tropical cyclones and parameterizations in the wave climate simulations. The empirical Gumbel quantile mapping method provided good results overall in reducing the biases with reference to the error 5. Also for the mean wave direction, which we did not show because we did not have much time, the differences between the original and the corrected projected changes are higher in the tropical and subtropical latitudes of the both hemispheres. This is possibly related to the widespread misrepresentation of tropical phenomena in these areas, namely the tropical cyclones, which are most visible for the significant wave height due to the coarse spatial and temporal resolution. And we can also see the effects of misrepresentation of swell attenuation, and this is most visible for the mean wave period. The differences are most striking, as I said, for the wave energy flux projections because it receives input from the significant wave height and the mean wave period as well. So thank you very much. I hope I was inside the time.
Thank you very much. So it's right on time, I think.
Okay, nice.
Thank you very much for your presentation. If anyone have question, please raise hands, and or you can write it down on the chat. Okay, while we are waiting, I have a question. So if I may recall, the Era 5 has 1 degree resolution, is that right?
No, the DDR5 for the wave parameters has actually 0.36, so almost 40 kilometers resolution.
40 kilometers.
So it's high resolution, yeah.
It's very wide grid, I think. So how is the results for archipelago areas such as Indonesia, where we have so many islands with complicated sea? How is the results for the analysis?
We can see great differences from I recall for the Indonesian archipelago. These differences, as I recall, for the significant wave height and for the wave energy flux as well, are negative. So we can see an enhancement of projected decreases that were also visible there, especially in the western parts of the archipelago. Then on the eastern part, so the part more close to the Pacific, we can see actually increases. So the differences are actually striking in the Indonesian archipelago, because the bias correction tends to increase the projected decreases in the western side of the archipelago and increase projected increases on the eastern side. So we can see great differences in Indonesia, which is one of the areas in which this application possibly has the biggest effect, because of the effect of the islands, which are not very well represented in the simulations, and they are better represented in Era 5, of course.
Okay, thank you. So I think it's very challenging area to simulate.
Thank you.
Yeah.
Thank you.
Okay, thank you very much. So I guess the time is up, and we thank you for your sharing. Thank you very much. Okay, and then we will continue to the next presenter for the paper entitled Conceptual Design of the LNG Dual Fuel System for Harbor Tap Towards Indonesian Green Port, presented by Mr. Fatola, Mr. Imade Ariana, Mr. Putra, and Mr. Ma'ruf. Who will present this paper? Please raise your hand. Mr. Ma'ruf, can you unmute yourself?
Hello.
Oh, Mr. Kusma Hamdana, are you one of the author?
Yes, I'm one of the author of this research.
Okay, you can share screen or
Let me share screen. Okay, thank you. I have seen my screen.
Yes.
Okay, thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Today I will present our research. My name is Gusma Hamdana Putra. I represent Mr. Agus Yudi Muhammad Fatala as a leader of our research. The title is Conceptual Design of Harbor Tap using a dual fuel system. This is our research. This is our presentation. They are the outline. Number 1, introduction. Number 2, methodology. And number 3, result. And number 4, conclusion. The background why we took this topic, because we have to be an Indonesian green port, such as we have to improve the quality of environmental in the port, and then we have to synergize with to each other and have to be a clean port and clean port. And number two, we have to introduce the high emission production. That this product is produced from the gas, exhaust gas from the shipping operation. That this product also dangerous for people's health, such as the sulfur content and nitrogen level. So in this study, we'll be optimizing from the several data that we'll consider, for example, the operational mode to determine the space capacity, the gasification unit, also the bunkering system. This is our step of our research. They are the literature study. We also review the other research for the determine our operational of say of Habertag, and then we also set up the design requirement. This means we have to determine what will we use to product the design of Habertag, especially on fuel system, and the selection of the method of type system or the type system. In this section, we have to select in several methods of in every system in fuel system, and then calculate the design requirement, and after that we design the conceptual of fuel system. Number one, we are also study about the operational mode criteria. Also, we have to determine in this section, we have to determine the parameter design of the operational ship actually in Habertag. In this section, we also determine two kinds. They are the operating time and the other hand, the kinds of operational mode. We took the researchers from the operational mode in Indonesian port. They are the highest or the busiest port in Indonesia, such as the Pelindo 2 in Jakarta and Pelindo 3 in Surabaya. The operational time would approximately working at 14 hours per day. That is the parameter, the main point of our design. And then we also taught the operational mode. They are starting engine, free running, tugging, emergency, and stopping engine. Number two, we also study Batok engine, diesel engine characteristic. In this left side, we can see that the combustion of dual fuel engine that determining into several kinds, such as type of fuel, engine power, engine durability, etc. And we also study about the characteristic of fuels, characteristic of dual diesel engine, and characteristic of dual fuel diesel engine. In this study, we took about the LNG fuels that has well characteristics such as anti-knock, higher thermal efficiency, and lower specific energy of consumption. In another hand, we also study about how to improve the energy performance to better, and then to improve the combustion process that will be better, such as the high pressure common rail injection. Number three, we also study about the LNG storage tank, that this design will be used one of the kind, the specific tank, but we also will be design and we will calculate the design. So we have to selection the parameters, including the design itself, and then placement of tank components, also the evaluation of tank materials. We also took the standard, the IDC code by IMO will be guided for our research to be construction and equipment. We also comparing from the other research and the other kinds of type of tank. They are pressure vessel single wall, pressure vessel double wall, and ISO tank. From this comparison, we choose the ISO tank as our tank as the design of harbor tug, because this fuel tank is flexibility and adaptable. And then the other regasification unit, the system that changing from the liquid fuel to be a gaseous fuel. We also make the selection of this type of regasification unit. There are 5 methods of the regasification unit. We also the comparing the advantage, disadvantage, working system. From this method, we choose the SCV or submerged combustion vaporizer, which is the adaptable to environment, and then the produce is high efficiency, also the able to utilize the heat from the exhaust gas propulsion as the burner of the SCV. In the fifth, we are the bunkering system. We also check the compare of the kinds of the bunkering system. This is a 3 type of bunkering system: truck to ship to ship, and port to ship. From this comparing, we also choose the truck to ship method due to this method will be limited movement and then less effect from the environmental or the weather, also the low capital investment, and then availability of prices for bunkering. From this methodology, we can gain the results. They are the operational mode from the harbor tug, which I stated before. The operational mode will be operated 14 hours per day. This is our operational mode from this design. They are start, stop engine, full speed, tugging, economic speed, slow speed, and maneuvering. This is a time for shift, time for day, power load of the engine, power load of the engine by kilowatt, and this is a diesel fuel and gas fuel as needed in this design. We also determine the total needs of this fuel per day, per 5 days, and per 7 days. We also we calculate the LNG storage of the harbor tug. The main calculation is the capacity, and then the loading limit, the volume LNG tank, also the design vaporizer. The table shows that this is a result of our LNG storage calculation. This is the PNID design of the LNG storage tank that we choose the type C or ISO tank, and we have calculated. This is a general specification of harbor tug tank, and the material, there are several kind of materials such as 9% nickel steel, austenitic steel, and aluminum alloy. From this calculation, we choose the highest allowable stress, minimal tensile strength, and minimum rate strength. So we choose the 9% nickel steel is the best quality of 3 indicators above. Also, we calculate and determine the regasification unit. The determination of regasification unit, we choose the SCV or submerged combustion vaporizer. Before we design of the PNID from regasification unit, we have to calculate such as calculation of fuel consumption need, calculation of boil of gas, also calculation the burner as the heat from this unit, but the burner is still going on process. In this storage, we also determine the amount of boil of gas, approximately set to into 0.1% until 0.15% volume of tank. And then this is a bunkering system. This is a design of bunkering system. We choose the truck-to-ship method, we can look into this PNID. This in the left side, the LNG truck. The tank in LNG truck will be discharged will be suctioned into LNG fuel ship that connecting the host. This selection bunkering is using a qualitative assessment. Then we have to choose based on flexibility in operation. So we choose the truck-to-ship method. From this analysis, we can conclude that the fuel system in this boat, in this harbor tug, using dual fuel system is determined 14 working hours per one day, and then divided by 6 operation mode, and then the fuel needs such as LNG and diesel fuel during per day, 5 days and 7 days. And number 2, we also select the operational, actually the tank that we use. We will use the Type C LNG tank or ISO tank. We have calculated the LNG requirement. We took during 77 days. They are 98.10 meter cubic per week, and the tank will be designed approximately 120 meter cubic, and they are the specification of tank. Number 3, the selection of regasification unit based on the availability installation and the higher economy, the higher efficiency, also able to utilize from the exhaust gas as a burner. So we choose the submerged combustion vaporizer. And the last, based on availability and flexibility operation, we choose the truck-to-ship method that we will use in this design. This is the end for me. Thank you.
Thank you very much, Mr. Gusma Hamdana. Yeah. Very, very interesting presentation. Anybody who have question can raise your hand or write down the question, please. Okay, while we are waiting, may I have a question, Mr. Gusma?
Yes.
So from your title, it's toward Indonesian green port. So what is actually the criteria of green port? How a port can be categorized as green port?
Actually, the categories, the Indonesian green port is one of several items. So we took one of the item that can able to say Indonesian green port, such as the reduce high emission that we stated before in our research. And 2, we have to reduce the quality environment, or we have to improve the quality environment. Like we have to increasing the operational mode of the shipping operation in port. So from this operation, from this design, we hope that the operational mode of the harbor tug that approximately 16% of the port, 16% of the all on board in this port will be comply with this idea that will be reach the Indonesian green port.
Thank you very much, Mr. Gusma Hamdana.
Thank you.
Any other question from the audience? Okay, I think that's it. Thank you very much. So we will continue to the next paper. Thank you very much.
Thank you.
Well, we will continue to the last paper, but we actually still waiting if the previous paper that not yet be presented join us, the presenter join us, so we will give a chance to present, but now we will continue to the next paper entitled Mapping Oil Spill Using Sentinel-1 with study case of Karawang oil spill, presented by Ms. Dian Puspitasari, Prof. Muktasar, and Mr. Muhammad Zikra. For the presenter, may you raise hand so we can, okay, Ms. Dian Puspitasari is already here. Okay. Please present your paper, 10 minutes. Thank you.
Thank you.
Okay, we can see your PowerPoint. Please have it in presentation mode.
Yes. Okay, thank you for the occasion. Okay, I will present my paper that entitled Mapping Oil Spill Using Sentinel-1, a study case of Karawang oil spill.
Can you full screen the PowerPoint? Full screen the PowerPoint, please.
Oh, it's not yet.
Not yet.
I have share screen.
Yes, I mean to make the PowerPoint for the presentation mode, so it's full screen.
Okay.
Not yet. Maybe you can click F5 for slideshow.
In my computer is already share screen mode.
Not share screen, slideshow. So the full screen.
Oh yes, yes. Slideshow already.
Here is
not
still
yet.
Not yet. Oh, sorry.
Wait.
Or we can help if you have difficulties. We can help to share your screen. Oh, okay. I think it's started. No.
Oh, wait. Yes, I think.
Okay, looks good.
Already, yes. At the mapping oil spill using Sentinel-1 study case of oil spill Karawang, the contents, introductions to the area, material and method, result and discussion, and the rest estimate collection. The first introduction, various kind of activities in the sea which cannot be denied that it can cause coastal and marine pollution, which affect the quality of seawater, such as oil and gas mining or sea voyage. And the focus is the coastal area that are sensitive and have high value for both humans and other biological creatures. That impact of pollution will greatly affect the survival of both. So we have to mapping the oil spill as one of the preliminary step to further step to oil spill assessment. So what is mapping oil spill? I use your satellite-based imageries provided by Prestiani and Abdul in 2018. They said that using satellite-based imageries provide opportunities to map oil spill in large scale effectively. So this is the advantage, of course. And the SAR is an active microwave sensor which captures two-dimensional image.
Okay, this is the introduction. Okay. This is the study area. As we see the red mark, this is the location of YYA1 oil well that on July 12, 2018, gas bubbles were seen in the located about 2 kilometers from the Karawang coast. Of course, it makes such damage in the area. Okay, material and method. First, data collection. Okay, all data all data acquired from ISF data search is open access. Sentinel data level level 1 GRD were used in the study. It's acquired in both VH and VV polarization, but we use just VV polarization because it displays oil spill more clearly than VH polarization. Okay, this is the interface of SNAP software. For who don't know, the SNAP software is very, very helpful to processing the Sentinel data. Okay, this is the processing oil spill mapping using SNAP software. First, we input the Sentinel-1 imagery and we geometric correction. Geometric correction is we actually choose the specific area because the imagery from the Sentinel-1 must be selected on the water. So the concern on the study is the oil slick over the water, not the land. And radiometric correction. It includes pixel filtering. It's to deleting the texture that set down the quality of the image. The goal of the radiometric correction is we can analyzing the backscattering easily. And then next to the dark spot detection. So we suspecting the dark spot that we suspect as an oil slick. And next oil spill detection, we detect the oil spill on that area widely. Okay, result and session. This is we can see the profile plot for amplitude VV. This is VV polarization. This is the pixel profiling. It's not obvious between oil spill and non-oil spill area. In red circle, this is the dB in oil spill area, and for rest of them is non-oil spill area. But if we look closely, we know that oil spill area have dB about 13, and the non-oil spill area is more than that, up to 17 in this case. Okay. So it appears as a dark spot in the imagery. The dark areas in figure oil spill detected on July 21st, 2019. It's just 3 days after the oil slick seen in the YYA1 oil well. Okay, so I used two data set. The first 21st July and the second in August 2019. Okay, if we look, this is more obvious the difference between the dB on non-oil spill area and the oil spill area. In the oil spill area, the dB is about 16, and the non-oil spill area about 20. Okay, so the difference is about 4 dB. we use the thresholding for dB or lower than that to extract pixel with oil spill. And this is the result for the second dataset. Dark areas in figure is detected as oil spill, which has a dB 16 or below. Okay. So from the images, the two image on, oh, I'm sorry, this is on August, not July. On August, August from dataset from July, 21st July and 19 August. This is 19 August. I'm sorry. We know that the oil slick moved from Karawang to the west area. From Karawang to west is Bekasi and Jakarta. Is to not move to north and northwest. Okay, it's the last, the conclusion. Sorry. First, as a result, oil spill were detected by applying an adaptive threshold. So we success to know that oil spill on this area. Second, the data used is on 19. I'm sorry, it's 19 August 2019. Oil has reached the western region of Karawang. So we know oil slick moves to west. I'm sorry. The third, it takes a validation process, of course, in field directly to find out the extent, the impact of the oil spill, which is I have not do that because of the situation, due to the situation right now. The fourth is mapping the oil spill using SAR image hub as an initial step in the response to an oil spill disaster. We can use mapping oil spill as to calculating valuation, economic valuation, or to make the oil spill clean strategy, or to make environmental sensitivity index, and etc. Okay, I think it's enough. Thank you.
Thank you very much, Ms. Dian. Okay, so if anyone has questions, please raise your hand or write down the questions. Okay, while waiting, I have a question, if I may. So in your results, you show that it's actually not so clear, the difference between the polluted area and the clean water, because it's like the dark area and very dark, so it's not so clear. Is it the limitation of the Sentinel-1, or I mean, I'm not so familiar with the Sentinel-1, but another satellite can differentiate between probably it's like if there are any mangrove, or is there between the sea and the land. So, but in this results, it's black and white. Is it the limitation of the satellite or any other reason?
To answer that, yes, this is one of the limitation of the Sentinel-1. So at the previous research, it sentenced that the Sentinel-1 is there is term most likely. Most likely is the slick that look like oil spill because of the shadow of water or slick of fresh water or other reason. Even the waves also make the oil look alike term. Look alike is like Yes,
Okay.
the term of light oil spill.
Okay, so
Yeah, this is the disadvantage from this usage of Sentinel-1 data.
yeah, maybe okay. There is a question from Miss Naura Salsabila. What are the advantage or maybe difference between similar software used for oil spill trajectory mapping? Do you compare with another method or software, or can you elaborate or explain why do you use Sentinel instead of other maybe oil spill predictions software?
Okay. Okay, thank you for the question. Sentinel-1 is common to detecting the oil spill, and the advantage, one of the advantage that I most like is that Snap that I mentioned before, Snap software. This is open source, so all of you can download it and processing the Sentinel-1 data. It is especially for Sentinel data. This is have oil spill detection, so we can say it's automatic. We don't have to maybe processing more time with more time or more effort, but we just like what I say, geometry. We selected the area and we do the radiometric and we suspect the dark spot as oil spill, and we calculate the dB. Of course, the Snap will do it for you. So it's so simple, it's effective, and yeah, of course, less time we use for detecting oil spill with Snap. This is the one of advantage, I think. This is advantage. So I
Okay.
choose the Sentinel data one and use Snap. Open source, of course, it's free.
Okay. Yes, I think I agree with you. So we can directly analyze the results. So probably for the further research, it should have more data sets, I think,
Yes.
to have like a, what is it, time in the time history of the oil spill. What is it? So in your conclusion, because you conclude that the result can be used to analyze the economical effect, to maybe the environmental effect. So probably you should have several data sets so we can have better analysis.
Okay, thank you for the sense.
Thank you very much for your presentation, Ms. Dian. So we can conclude this paper and we will continue to the next one. So there's additional paper from Mr. Sutopo. The title is Design of Reverse Osmosis Desalination Plant at Remote Coastal Area. Please welcome Mr. Sutopo.
Okay, thank you, Bu Sade.
Thank you very much.
Let's start. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. So this is my second paper for ISOCEEN. So my name is Sutopo from Marine Engineering Department, ITS, and today I'd like to present our result of the research with the title of Design of Reverse Osmosis Desalination Plant at Remote Coastal Area. Doesn't move. Okay, this is my outline presentation today. So let me talk about the water crisis. Yeah. The water crisis can be caused by the several factors like climate change, the high population growth, the land use change, and also the groundwater exploitation. And because of the water crisis, we have facing several problems, yeah, like limited access of clean water, many crops fail, and also hygiene and sanitation, and also especially for children, yeah, get vulnerable to disease. So this is a big problem for our next generation. So we have also some data or crisis in Indonesia last year. Many villages suffered clean water, yeah, especially in the East Java, yeah, and also in other province. We got the data, many land has no crops, no harvest, and also millions of people suffer from clean water. And also this year, yeah, because also quite long dry season, 58 district, yeah, has extreme dryness and also warning to get the dryness condition. So how to help end this crisis? The first important thing is to save the water. Yeah, so we cannot use spend water in unimportant things. Yeah, and also the reducing the groundwater exploitation and maintain the existing wells. And maybe also the rainfed system also can be used during the rainy season. And also, of course, we have an alternative using the water processing technology like desalination. So this is the fact that we can make out these problems. Yeah? So because Indonesia is an archipelago country, and also we have 70% area as a seawater, and also majority of Indonesia population also lives in the coastal area. And it has still only 80% it has access of clean water. Yeah, and also we have abundant solar energy, about 4.8 kilowatt hours per square meter per day. So it is a big potential energy for water processing like desalination. And also there are other facts that the seawater desalination is still the dominant water processing technology compared to the brackish water desalination. And also nowadays the development of reverse osmosis is advanced, and also more development to get low cost and also low energy consumption. And the photovoltaic reverse osmosis desalination is an energy efficient, cost competitive, and modular. It is also fit for the coastal area or remote coastal area that there is no supply of electrical power. Yeah, and also the PVRO usually recommended still as a small size plant, yeah, until 50 cubic meter per day for seawater reverse osmosis. So, and the PVRO, compared to the other method of desalination, it is still a big technologies has been applied in the worldwide water processing technologies. And so in this picture, we can see there are many technologies for water processing like photovoltaic electrodialysis, the hybrid with the diesel generation set, and also wind turbine and reverse osmosis, the filtration, multi-stage filtration, and also wind mechanical system. So in this research, we have objectives. Objectives are we want to design medium size, yeah, because based on the reference, usually the photovoltaic reverse osmosis usually recommended as a small size plant for reverse osmosis, but we try to make a medium size with 100 cubic meter per day. Yeah. So of course we have to pay attention about the power supply and also the system or method for reverse osmosis. And in this research, we need to know the requirement of system for PVRO and what is the capacity profile based on the energy management, and also the concept or layout for the application coastal area. So this is the method. So we use wave simulation software and also red screen expert software to simulate some calculation required for the design. So this is the results. The first thing about the location. So we have decided that the remote coastal area, especially in the East Java Island, with some places, some villages has suffered clean water access. Yeah? So in the south part of the Pacitan district, it is the Sudimoro village. Yeah? This is near the coastal area. So we have a project to put the PVRO at this village. So this is the configuration plan. So we use a PV cell array. This is the inverter, battery, and MCB, and also combined with the diesel genset. This is the ultrafiltration. We use ultrafiltration membranes, and this is the high pressure reverse osmosis membrane pump. This is the RO membranes, and also we use this is ultrafiltration pump, feed water pumps, and the product water will be collected in the product water tanks. And the brine water will be rejected to the surrounding system. So this is the spec, as I mentioned before. So the RO membrane calculation, we use wave software to simulate the membrane. We chose field tech from DuPont with the type 440 square feet. Yeah, we need 6 membranes, and the permeate flow 4.17 cubic meter per hour, and the TDS of the product water is 111.8 milligram per liter. Yeah? And also the pH is 8.1. So the values here, the TDS and all the pH, the pH also meet the requirement from the regulation, initial regulation. That is the permanent gas number 32. So for the ultrafiltration membrane, we use the ultrafiltration to filter out any colloids, bacteria, microorganisms before entering the RO membrane itself. So we use DuPont UF membrane integral pack IP77 with the recovery rate 69.08% with one train module, and we need 8 membrane. So the ultrafiltration should produce 9.3 square cubic meter per hour. And then this is the all required RO components. So the important component in the reverse osmosis system is the high pressure RO pump, because this pump required a very high power with the high pressure. It is about 80 bars. Yeah, so we need 30 kilowatts. So the system has a specific energy consumption 7.2 kilowatt hour per cubic meter. So this is a normal specific energy consumption for seawater reverse osmosis, because usually in the world for seawater reverse osmosis ranged from 3 until 10 kilowatt hour per cubic meter.
Excuse me,
yeah,
Mr. Topo. So the time is less than 2 minutes. So please
okay,
wrap up your question. Thank you.
Okay, this is for the PV system. We use monocrystalline silicon for PV cell, and there are 3 configurations. So this is the 3 configuration. We had the calculation requirement of number of solar panel, inverter, and PPT and batteries, and this is one of the configuration of the energy management system. So we have 4 options. This is very flexible, and I think this is very advantageous for people and the remote area to choose whether which one is the best or fit the requirement to produce clean water. Yeah. So this is the capacity between all the options. So the maximum product capacity is 100 cubic meter per day. So this is the layout that we have designed. So this is the conclusion for our presentation today. Thank you very much.
Thank you very much, Mr. Topo, for your presentation. Okay, ladies and gentlemen, if you have questions, please raise your hand and or write down the question on the chat room. Okay. So I will have a question, Mr. Topo. So the desalination plant is designed for remote coastal area. What is the most affecting, significant, what is it, factor for the successful of the system?
Yeah, because usually in the remote coastal area, they have no supply of electrical power. Yeah, the off-grid from PLN, for instance. Nowadays, we can see in our small islands, for example, and also the still many areas in the south part of Java, in the Madura Islands, in the Sulawesi, Sumatra, and so on. Many areas still have no electricity. Yeah, so the most applicable of the ROT technology is the PVRO, the photovoltaic reverse osmosis. Maybe the other technology like hybrid wind turbine, or maybe with hybrid with diesel generator also possible. But of course, if you use diesel generator, we need fossil fuels. We need the solar. And sometimes in Indonesia, in the small island or in the outer island, yeah, it is still difficult to get the fossil fuel or solar. So the PV, photovoltaic solar cell, I think the most suitable for this kind of technology for water processing in the remote coastal area.
Thank you very much, Mr. Topo, for your answer. Okay, I think there is no other questions, so we will wrap up this session. Thank you very much.
Okay, thank you.
Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
So Thank you very much for all the participants of the parallel room number 3. Perhaps you still have any question or you want to discuss, but unfortunately we have time limit here. And thank you for all of the presenter and the audience. Now I think I will give back this room to the MC. Thank you for your participation. I hope you enjoy the program, and I look forward for your participation in the future seminars. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, moderator Ms. Sade, and also interesting presentation by all the participants. Ladies and gentlemen, I'm taking over the room again. Next, we will take a photo with the participants, and you are pleased to turn on your camera because the committee will capture the photo. Once again, please, for all participants, to turn on the camera because we will have the photo session. For all the participants, once again, we are pleased you to turn on your camera. We will have the photo session for room 3. Hold your smile. Okay, thank you. Ladies and gentlemen, that is the last agenda for today. Before it really ends, we will watch the closing speech of ISOCEEN seminar by Mr. Herman Pratikno, STMT PhD, as the head of Ocean Engineering Department ITS.
Assalamualaikum warahmatullahi wabarakatuh. Good evening for all participants, speakers, colleagues, and ladies and gentlemen. I believe that all of you have well done through this 8th International Conference ISOCEEN 2020. It is my great pleasure that your presentation and discussion that I think this full day is not enough. I will take you to understand the different and promote mutual understanding among the participants to the conference. I observe your excellent presentation and active discussion, so I can conclude that the purpose of this conference has been absolutely accomplished. The contributions are from over 300 participants from 2 countries, Indonesia, Japan, Netherlands, Oman, Qatar, Germany, Portugal, Spain, Vietnam, Malaysia, and Korea. I sincerely hope that new friendship will last long time and help for me and you to make better contribution in your surrounding area. The selected paper will be published in the IAOB conference series Earth and Environmental Science ESS Index in Scopus. Finally, I would like to express my appreciation to all committee and participants for taking time out of your visiting day and attend to this conference, the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020, with virtual seminar in Department of Ocean Engineering, Faculty of Marine Technology, Institut Teknologi 10 November, Surabaya, Indonesia. By saying Alhamdulillah, I would like to close my remark and officially announce with end of the 8th ISOCEEN 2020, wishing the future of all participants. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Herman Pratikno, for the closing speech. Now, I would like to announce for the best top 3 paper. The operator, please share screen for the announcement of the best top 3 paper. Congratulations for detection of time behavior of extreme rainfall over Java using man candle by Suroso Isaac Aksakifari Purwanto Bekti Santoso. Next. Congratulations for evacuation analysis of ship passenger using agent-based modeling simulation by Abi Zaman and Siswantoro M. Zulfikar. And the last one, congratulations for bias correction of single forcing dynamic ensemble of wave climate projections toward the end of the 21st century by G. Lemos, Esimedo, M. Dobrinin, M. Menendez, and P. M. A. Miranda. Now I'd like to say thank you for Mr. Associate Professor IR, Doctor of Engineering Ahmad Fitriadi, Senior Lecturer, Department of Maritime Technology, Faculty of Ocean Engineering Technology and Informatics, University Malaysia Terengganu, as the invited speaker. Thank you, Mr. Doctor of Engineering Purwanto Bekti Santoso and Mr. Miss Doctor of Engineering Sadi Rahmawati, STMT, as the moderator, and also all participants of ISOCEEN 2020. It has been my pleasure to host this event. We look forward to seeing you at the next year event. Thank you once again, stay healthy, and goodbye.